our Honorable Vice Rector, Professor Hadianto, and our Honorable Dean of Faculty and Mathematics, Diponegoro University, Professor Koswaradi, our Honorable Vice Dean Resources in Faculty of Mathematics and Sciences, Dr. Eng Adibawa, our Honorable in Coordinator or Chief of this event, Professor Eng Agus Setiawan, and our Honorable Speaker in this session, Professor Nisisima, I not, no, and all participants. Alhamdulillah for this morning. We meet in a condition safe and healthy, and this event is very important to encourage and development of geophysics science. Welcome to Department of Physics in Semarang, and I hope this event can improve and development, especially in geophysics science. And I hope the next time, in the future, we have strong collaboration until education and research collaboration, and especially in the speaker. Thank you very much for your available time to keep the lecture in session. And overall, and all participants with the online or offline session, we say thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
After this, we will have a greeting from Kyushu University presented by Professor Dr. Juni Shijima and Professor Keigo Kitamura.
Good morning, everyone. My name is Keigo Kitamura from Kyushu University. I'm here leading a student from Kyushu University, Kyushu University's cooperative program for resource engineering. I would like to express my gratitude to all Undip people, especially Agus Sensei, organizing and preparing this summer course program. Thank you very much. And I would like to express thank you for the fantastic dinner yesterday. It was a really special evening for us. We enjoyed the wonderful food, sing, and dance. Especially Agus Sensei singing is amazing. So thank you very much. So this is the first time for this summer course. I believe it will be excellent, wonderful experience for our Kyushu University students. And I hope Kyushu University students will enjoy this experience and learn a lot from all Undip people. And I also hope this program will continue for many years and build stronger relations between and Kyushu universities. Thank you very much. Terima kasih.
After this, we shall proceed to the Dean's speech provided by Dr. Kuswara.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Honorable Professor Hadianto, Director of Global Connectivity, represent of Vice Rector 4. Honorable Associate Professor Jun Nishijama and Associate Professor Keiko Ketumura from Kyushu University, Professor Agus Setiawan, Head of Committee, Head of Department of Physics, Professor Heri Sutanto, all speaker, esteemed colleagues, student and participant. Good morning, everyone. Welcome to Geoexploration Summer Course in Faculty Science and Mathematics. And this morning is very healthy and very happy to lead the activity. And thank you very much for Prof. Nisishima from Kitumara for in our summer course to share about the expertise, about the knowledge, and so maybe in the next we must do collaboration. How to collaboration about the joint research, joint publication, and so to we open to the opportunity. And thank you for the committee to prepare this activity with work hard. And especially thanks for Department of Physics to is the this activity. So to the participant or my students, this activity not only academic, but we can to study about networking and collaboration, how to more collaboration with other university. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.
Now we will proceed to the plaque awarding from Diponegoro University to Kyushu University, which is represented from Professor Dr. Engineer Hadianto from Diponegoro University towards Sensei Nishijima from Kyushu University.
Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Good morning, everyone. I would like to greet some important persons here first before I start with my speech. The Honorable Dean, Professor Kusworo, the Dean of Faculty of Science and Mathematics, and then the Head of the Department of Physics, Prof. Heri, and the Chairman of the Summer Course, Geoexploration 2025, Prof. Kustiawan, all the Vice Deans, Pak Adi, and also the special guest, Nishijima Sensei and Kitamura Sensei. Welcome to Undip. And all the participants, which is available online and also offline, presented our presentings in this summer course today. I heard also from Prof. Agus that the participants registered to this summer course is already over than 200 participants coming from more than 8 countries. It's very wonderful summer course that conducted by Faculty of Science and Mathematics. Ladies and gentlemen, it is very great pleasure to welcome you to Universitas Diponegoro as one of the leading university in Indonesia, and currently we are also on the top 600 in GS World University ranking. And this kind of activities, summer course, is really supporting our academic reputation as well as our academic recognitions. Therefore, we also have other faculties to conduct this kind of program. Since 3 years ago, we have a world-class university program which enable each faculty conducting or hosting this summer course. And also enables each faculty to invite international scholar and also international students to come to faculties in Diponegoro University. And this time, Prof. Agus and the team host a summer course in geoexploration. I think geoexploration is very important as Indonesia is the second largest of geothermals uh, in terms of the energy capacities after United States and Japan. I think is the third largest in terms of the power capacity that they have. Although they have the third largest in geothermal capacity, but maybe their technology is advanced, more advanced than in Indonesia. Therefore, we should learn more what the Japanese technology for this geothermal production. Special thanks I would like to give to Nishijima Sensei and Kitamura Sensei for your presence today and giving lecture and also introducing technology, especially for the geothermals, to the participants. And also, I would like to thank all the participants from Kyushu Universities, 11 students that presents today. I hope you will enjoy the summer course. Please use the summer course not only for getting knowledge, but also to get more networks, building partnership with student from Faculty of Science and Mathematics, and this can be used for next year collaborations. And I hope Prof. Agus also can make a second summer course next year with more participants from around the world. I think that's all what I can say to you, and the dean will open this. Okay, on behalf of the dean and also all the participants, this summer course is officially open. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.
And now let's proceed to the plaque awarding of appreciation. May I call Dr. Insinyur Hadianto from Diponegoro University to present the award to Sensei Nishijima from Kyushu University. Now we will proceed to the plaque awarding of appreciation. May I call Professor Dr. Kuswara Adi from Diponegoro University to present the award to Mr. Agustia from Brin. Now for the last, let us proceed to the plaque of awarding of appreciation. May I call Professor Harry Sutanto from Diponegoro University to present the award to Bahmut Yusuf from BMKG. Now let's take a short break and proceed with photo documentations. Please stay in the hall for group photos. Dear friends and guests, there are snacks and drinks provided at the left counter. Feel free to take the snacks and the drinks. Dear guests, now we will introduce our moderator for the first session, which will be Miss Janina as the moderator of this session. Miss Janina also completed a study from Universitas Diponegoro as Bachelor of Engineering and Universitas Gajah Mada, which is Master of Engineering too as well.
Warahmatullahi wabarakatuh. To the honorable speakers and instructors, Prof. Agus Setiawan, Nishijima Sensei, Kitamura Sensei, Bapak Agustia, Bapak Yoga, and Bapak Udi Harmoko, and all of our guests and student distinguished participants. I'm a lecturer from Department of Geological Engineering. I will be serving as your moderator in this morning session at Geoexploration Summer Course 2025. As we know, this course discusses geothermal exploration with a case study specific in Gedong Songo area near the Ungaran volcano. In today's workshop, we will get an overview about it before we take a closer look to the field in the field trip the following days. Ladies and gentlemen, before we proceed further, I would like to give a brief introduction to our speakers in this session. Coming up, our first speakers, Prof. Agus. Please, can you show the CV? Okay, this is our first presenter, Prof. Dr. Eng Agus Setiawan from Department of Physics. Prof. Agus is a professor from Laboratory of Geophysics, Department of Physics, Undip. Educational background, he had his bachelor in Universitas Diponegoro and master degree of geophysics from Universitas Gadjah Mada, and then doctorate in geothermics, Kyushu University. For the area of expertise, Prof. Agus is an expert in non-seismic models and geophysics. Okay. So, Prof. Agus, are you ready for the presentation? And the time is yours.
Okay, thank you, Mbak Jinian as moderator. Okay, good morning, everyone. I'm very happy in here in this class for summer course. Honorable Nishijima Sensei, also Kitamura Sensei, and all participants. Today I would like talk about the overview Ungaran geothermal system. So it's very happy because this morning we talk about Ungaran volcano. This volcano is very near with our university, maybe only 1 hour maximum to go there. And I will try to overview about the geothermal system in Ungaran volcano. So next, please. Okay, please use PPT file, Mas Zaki. PPT file. So back the outline today I work first we going to introduction, and then we going to the field characteristic of Ungaran volcano. In this part we will talk about geologies, geochemistries, and then we going to apply geophysical methods at Ungaran volcano and then make some conclusions. Next. So as we know that the geothermal energy is a renewable energy from the Earth's core. It's come from heat generated the original from our planet and the radioactive decay material. This thermal energy is strong fluid in center of the Earth. So this is the tectonic in our Earth, and source become like this. Next. Why we choose geothermal energy? As we know, geothermal energy is clean and renewable energy until now. And then effective use of indigenous energy resource and no fuel necessary. For geothermal system, we study like this. We imaging. We cook the water. So sometimes in here we add heat reservoir, also the fluid, including water and gas, and then the cap rock, like this for geothermal systems. Next. So as Prof. Adianto said in the open ceremony, now the resources in Indonesia in the second place in the world. There. And the capacity installed now is the 2036,540.43 megawatts. Okay, next. Next, Zaki. For study about geothermal, actually we have three geoscientists, including geology, geophysics, and geochemistry. From geology, we have tectonic setting, permeability, heat source, and lithology. From geophysics, we have a reservoir geometry, also another fluid patterns. And from geochemistry, we have hydrology, upflow zone, type of fluid, and temperature of reservoir. So if we have all of that, we can make some conceptual model beneath the geothermal prospect area. After that, we can make some drilling. So in this situation, we call it the explorations, geoscientists, and then if we already drilling, say the exploitation like that. Okay, next. Ada pointer. Okay. This is location of Ungaran volcano. Yeah, this is Ungaran volcano. Ungaran volcano is located in the central Java in Indonesia. As we know, Indonesia have three plate tectonic, and here we have Indo-Asian Australian tectonic, and then in here we have Eurasian plate tectonic subduction like this, almost 6 centimeter a year. The Australian Indonesian plate tectonic slip in this area. And other hand, we have a Pacific plate. So there is many volcano during from Sumatra Island, Java Island, until this area. And we will talk this area about Ungaran volcano. So this is the Ungaran volcano. As you can see in here, Ungaran volcano, there are two fields in if we going to Solo from Semarang by highway to Solo. So we can see Young Ungaran in the southern part and Old Ungaran in the northern part. And special in Gedong Songo area, in here, we have so many, Ungaran have so many manifestations. For example, in here we have a active fumarole with a temperature 91.4 degrees Celsius. Also, we have they have acid sulfate hot spring. The temperature 68.4, and rock acid fluid and shallow ground temperature about 97 degrees Celsius. So it's very interesting for study previous about the geothermal manifestation. Okay, the geology, Ungaran volcano located in Solo zone. We can see in here Solo zone including Merapi volcano, Merbabu volcano, Telomoyo volcano, also the Ungaran volcano. So in the west side we have Dieng, Sumbing, and Sindoro. So all are located in the Solo zone. Geologic setting of Ungaran volcano. Basically, Ungaran volcano divided in 3 parts. Yang Ungaran is from Gajah Mungkur volcanic, consists of andesite. And then all Ungaran volcanic consists of basalt flow, and then the tertiary from Kerek formation. And here we can see also some manifestation located in several places. And this is the main manifestation located in Gedong Songo area. Also in the northern part we have Ngelimut, Diwa, Kalisodo, and some part in the southern part. Okay. The age of Ungaran volcano from Pemelon, the age is 3 part. Proto-Ungaran, Old Ungaran, and Young Ungaran. So now in Miocene age, this one. And then some information I got from previous study. You can see in here that from Tendon, we have a quaternar volcano, series of andesitic basaltics. As I preface, there are Young Ungaran is andesitic and Old Ungaran is basaltic. But we didn't find the eruption historical time. So there are many geothermal manifestation, and from Konosang 2006, he get already published that Ungaran, Old Ungaran of 500,000 years, and the Young Ungaran 300,000 years ago. And from geochemistry, Widarto, jadi sensei is my sensei also when I am undergraduate. The temperature reservoir predict from 120 degrees Celsius up to 290 degrees Celsius. And the other reviews as geochemist from geochemistry, there are Ungaran divided in 2 distinct types. One is sulfate water around the Gedong Songo area, and the second one is bicarbonate water in another area like Banaran, Andalisoto, Diwa, and Kalulo. This is information I got from previous study from geology and geochemistry. And this is from Konosan about the silica content and also proof that the Old Ungaran consists of basaltic trachyandesite, and the Young Ungaran is trachy andesite, almost andesite and basaltics. So I would present about the geophysical observation, but it's very basically, there are three methods in here: gravity, spontaneous potential, and micro earthquake. This survey I took that when I study at Kyushu University at that time. We survey with Nijijima Sensei, Ehara Sensei, also Fujimitsu Sensei. Yeah, I will remember. It's a long time ago, Sensei. For gravity, I got from Kacamata University. We took that I'm a master student in Kacamata University. There are 172 gravity station like this, and equipment is all equipment Lacoste Rombux G11X. This is all version, but no, the gravity is coming CG6. Yeah. Okay, this is the result from gravity boogie. We have a high anomaly gravity boogie in the northern part. This is correlated with the old Ungaran volcanic with density around 2.64 kilogram per cubic meter. And another area is under Yang Ungaran in the southern part, which density is 2.4. 2.39, I think, about 2.4 kilogram per cubic meter. So the high boogie anomaly related the all Ungarans, and the other is Young Ungaran. Okay, we applied a horizontal gradient method. Horizontal gradient method like this. From gravity, divide the horizontal x to and y. So we constant in the maximum value in here. From horizontal gradient method, we detect like this in all manifestation. For example, Gedong Songo, Banaran, Kendali Soto, Diwa, and Ngelimut. Is we interpret a fault area. So the manifestation geothermal controlled by fault structure, I think, in this interpretation from horizontal gradient. Okay. So we could also conduct some measurement density with Konosang. We take some sample in here and clarify that the value of gravity is 2.6 and 2.4. Now we're going to spontaneous potential to understand about the fluid pattern. From this measure, we have a 5 line. Line 1 in the northern part of Gedong Songo area, line 2 in here, and line 3 the gate outside, and then line 4. So we get the result. The maximum outflow zone located in the northern part, and the manifestation, we have low value of spontaneous potential, but in here we have a low and high. So we try to interpret like this. The main outflow zone near the collapse wall in here, we compare between SP distribution, also the topography. So in the main upflow zone and in the collapse wall, and then this maximum. After that, the geothermal fluid flow laterally going down, and like this, and appear this area in fumarolic area, and then discharge to the surface. Next, this is the relation of altitude and SP, almost positive correlation. Then this is a seismic. At that time, Dr. Udi had us to observation this seismic. So we have 270 seismic event during recording for 4 days observation. So it indicated Ungaran volcano activity for fluid is very active. Also, we detect the clear seismogram in here. This is P arrival and S arrival time. Then, sorry. And we got the distribution of hypocenter. As you know in here, not more than 700 cell, the activity of seismic activity. Okay, so I will try to some conceptual modeling for fluid pattern. The fluid pattern like this, meteoric water comes to the up and then mixing in the by heat source in here, and then goes up, we get the positive anomaly, and then goes down in here. Some part is here in here, in fumarolic area, also hot spring area, and then goes down directly. Like gravity, something like this. Next, this is our conceptual model also combined between geophysics. From gravity, we have young Ungaran volcano, old Ungaran volcano, and tertiary volcano. And we got a seismic activity using seismic. And then the fluid coils up. We have upflow near the Gedong Songo manifestation, and then going down some part of in the another hot spring like Diva and Kaliulo. It's about the downflow. Okay. So the final is I make some conclusion. Ungaran volcano is quaternary volcano, which consists of young Ungaran with density 2.3 and old Ungaran with average density of 2.6. Generally, Ungaran area is discharged by fault east and west and northwest to southeast direction. Moreover, from horizontal gradient method, gravity is a regional component. So the fault structure is controlling the geothermal manifestation located in the young Ungaran volcano. And the upflow of hot water occurs beneath the collapse wall area. After that, the geothermal fluid moved laterally, and then some portion of geothermal fluids discharged on the surface in Gedong Songo manifestation or fumaric area. From seismic, we detect 270 micro earthquake, including 4 seismic swamp. So this is a lesson that fleet is active in Gedong Songo area. So we conclude also the hypocenter distributed in the shallow region around collapse wall. Okay, this is my presentation, small presentation for introduction for Ungaran volcano. Hopefully you can enjoy this presentation. Thank you very much.
Okay, thank you, Prof. Agus, for the comprehensive presentation. Obviously, as a local resident of Ungaran volcano, Pak, I want to know more about, especially the geothermal, geophysics, and geochemistry aspect of Ungaran. So does everybody in this room, I think. If you have any questions, please keep it until the end of the session, because the Q&A session will be given in the last after the third presenter. Ladies and gentlemen, we will continue with the second part of this session. So for the second speaker, we have Mr. Yoga Aribowo as our speaker. Please wait for the preparation. Maybe we can show the CV from Pak Yoga first. Pak Yoga is still arranged general lecture in our department, Department of Geological Engineering. That will be given by Kitamura Sensei. Excuse me, Nishijima Sensei, may you give the second presentation? Oh, there's some slight change for our next speaker. Our second material will be delivered by Nishijima Sensei. Can we show the Nishijima Sensei CV, please? Yeah, thank you. I will give a brief introduction to our second speaker. We have Associate Professor Dr. Nishijima Jun from Kyushu University. The educational background is from Kyushu University, and he has the area of expertise in geophysics, especially gravity and geothermics. From years of study and research, we can see here the specialty and the keywords related to his publication, like in supercritical geothermal research survey, geothermal area, volcano, hot spring, active faults, groundwater, CCS, and Antarctica. Okay. Today, Nishijima Sensei will give us the topic about gravity for geothermal exploration. Nishijima Sensei, pleasure to meet you. Are you ready for the presentation? So, and then the time is yours. Yes, please.
Good morning. My name is Nishijima. Today's my talk is about the gravity survey for geothermal exploration. So I usually measure the gravity, not only geothermal area, but also the detecting the active fault and monitoring for the CCS. And sometimes I measure in Antarctica for the global warming. So today I will focus on the geothermal exploration. So this is today's contents. So at first I would like to talk about gravity field, and then instrument and gravity survey, application of gravity survey, and gravity gradiometry survey. This, こっちか。So this is the gravity field. So gravity force, maybe you know well. So this gravity force consists of two parts. So one is a gravitational acceleration. The other is a centrifugal acceleration. So because Earth is rotating. So about this centrifugal acceleration, so this force is depending on the distance from the this axis, rotation axis. So the longest distance is at the equator. So the centrifugal acceleration is maximum. And at the pole, so the acceleration is minimum. So because of this centrifugal acceleration effect, so the gravity is different. Gravity value is different, about 0.5% at the pole and equator. So the pole is bigger than equator. So when we calculate the gravity force, so we can use this equation. So one is a gravitational acceleration. Maybe you have already done physics. Also, you know the Newton's second law, or F equal ma. So using these two equations, so we can get the acceleration. And the gravity is a vector. So there are three components, x-axis, y-axis, z-axis. But usually we use the only z component for the gravity survey. Okay. So the gravity is a special derivative of the gravitational potential. And gravity is a vector. So we usually use a z component of gravity vector. Currently, we can also measure the gravity gradient. So this gravity gradient can get from the spatial derivative of the gravity vector. So the gravity gradient is a tensor. So it means there are 9 components. So I will introduce the application of the gravity survey and the gravity gradiometry survey today. For the calculation, so we need a modeling. So when we calculate the gravity, so we use only the component of the previous slide. But it's difficult to calculate using this equation for the computer. So we need to transform the equation, this equation. So this one is a transformed equation. So when we use this equation, so it's easy to calculate in the computer. A little complicated, but only we use the vertex of the here and here, and that density contrast. And next is the unit of the gravity. So currently we need to use the SI unit. So the gravity unit is meter per square second. And also you usually use a 9.8 meter per square second for the physical calculation. But old unit is used for the gravity survey. So we usually use GAL. So we need to change to use SI time. But I cannot use SI time. So when we need to convert, so sometimes I confuse. So this time I will use the old unit GAL. So GAL is 1 centimeter square second. So 1 GAL equal, so this one 0.01 meter per square second. But in gravity survey, usually use 1 milligal or 1 microgal. And when we conduct the gravity monitoring, sometimes we use 1 nanogal, very small. And so this is a 9.8. So this is a mean gravity value. So current gravimeter can measure this digit. And this red digit indicates the milligal order. So usually this milligal order reflects the underground structure, especially the big structure. And this last 3 digits called microgal order. So the small structure or the underground fluid monitoring. So geophysical survey in the geothermal field. So there are many methods. So the temperature and electrical conductivity, our resistivity, and propagation velocity, and density and magnetic. So today my topic is density distribution. So gravity survey can use for the many purposes. So today I will talk about the gravity survey, but except the gravity survey, so there are many purposes: exploration of fossil fuels, cavity detection, glaciers, regional and global tectonics, geology, volcanology, shape of the earth. So there are many purposes. But today I will focus on the geothermal survey. So the next, the instrument. So how to measure the gravity? So there are many methods to measure the gravity. We can use a satellite, and airplane or helicopter, and ground surface survey, borehole, marine, and sea floor. So this picture show the some type of gravimeter. So I took this picture in the Antarctica gravity observation room. So in this room, there are many type of gravimeter. So it's difficult to take a picture in many kind of gravimeter. So you can see here, you can see this one and this one. So this two is the absolute gravimeter. So we can measure the 9.8 something directly. And here is a Syntorex, so relative gravimeter. We cannot measure the 9.8 something directly. So we can know only the gravity difference between the 2 points. And the other is a superconducting gravimeter. So the very sensitive gravimeter. So we can detect the very small gravity change. So including the surface water change. Or sometimes in Antarctica, so we can detect the ice melting. So how much ice melted. So there are many kinds of the gravimeter. But basically, in a ground survey, so the measurement method can divide two methods. One is absolute, the other is relative. So the absolute is we can measure 9.8 something directly. Relative, so we cannot get 9.8 something directly, but we can know the difference between the 2 points. So this is the instrument. So this is our instrument. So absolute gravimeter and relative gravimeter. The difference is measurement time. So for the absolute gravimeter, it takes about 30 minutes. And for the relative gravimeter, so the measurement time is 1 to 2 minutes, so very short. But this absolute gravimeter can measure the 9.8, but this type cannot get, so we need a reference point. So this is a different. And absolute gravimeter is so there are many parts. So we need to carry by car. So we need the required space is 5 by 5 meter. But for the relative gravimeter, so this gravimeter is very compact. So the required space is less than 1 meter by 1 meter, maybe less than 0.5 meter. And accuracy is almost same. But relative gravimeter can get 9.8 something directly. So I think it's better to use this one. But the problem is the price of the instrument. So the absolute gravimeter is this one. So I cannot count. So there are many zeros, but very expensive. So, but relative gravimeter is not so expensive, but enough expensive. Yeah. So this is a problem. But so I measured the absolute gravity in Undip campus using this gravimeter. Maybe only one station is remained. If you want to measure the gravity using relative gravimeter, so you can use for the reference station. So the principle of the gravity measurement is very in case of the relative gravimeter, it's very simple. So there is a vacuum chamber in the instrument, and in the instrument, so that there is a spring and weight. So if the gravity is changed, so that this spring is extended. So if we measure this extension very precisely, we can get using this formula, so we can get a gravity difference. And so this is a picture of the relative gravimeter. So that this one is a previous model, Centrex CZ5. Sorry, this type is very popular in the world. So Centrex in Canada manufactures. Currently, the new type is a CZ6 new model. So getting smaller, and size and weight is getting smaller. So currently, the weight is 5.2 kilogram. So very light. So before CZ5, so the CZ3 is the oldest model. That model was 15 kilogram. And I and Agus Sensei bring this old type and climb the mountain many times for the volcanic monitoring. So, but currently it's easier to conduct gravity monitoring using this small one. And absolute gravimeter. So the principle is a little complicated. So there is a vacuum chamber in the instruments. So this is the same as the relative gravimeter. But inside of the vacuum chamber, so there is a cut, and prism is on the cut. And cut is moving to up, then down. So when they are falling, so free falling, so we measure the time from start the falling and the distance from the bottom. So in case of this gravimeter, so the distance, free fall distance is a 7.5 centimeter. During falling, so we measure the 1,200 pairs of time and distance. Then plot this pair. So the time is for the lateral axis, and the distance for the vertical axis. So the red point is a measured value. And we fit the free falling equation. So from this, fit this equation, so we can get the gravity value. But if we drop only once, so the accuracy is not so good. So usually we drop 1,000 drops. But it takes about 30 minutes because we can drop every 1 second. So we can get a gravity value very quickly. If we drop 1,000 drops, so we can get the 10 microgram accuracy. So this is a superconducting gravimeter. So this is a kind of relative gravimeter. So inside of this blue one, so there are two coils. So under a niobe sphere, so the metal niobe sphere is locating between the coil, and the floating this metal sphere is floating between these two coils. If the gravity changes, so this niobe sphere location is moving. So this movement is corrected by these two coils. So we can get a very small gravity change. So the accuracy is 0.01 to 0.04 microgal. So this means 10 to 40 nanogal. So very sensitive. But it's difficult to bring to the field survey. So because the instrument is very big and very heavy. So this is a different type of gravimeter. So the airborne gravimeter. So when this instrument is carried by airplane, so we can get the boogie anomaly like this. So if the terrain is, topography is very steep, so it's difficult to access. So the spatial resolution is not so good. But if we use the airborne survey, so it's easier to get the good spatial resolution data. But the accuracy is less than ground survey. So this is a problem. So this is airborne gravity gradiometry. So we can measure the gravity gradient. So I showed the beginning of the my talk. So we can measure the, this 9 component. So so there are 9 components, but this TYX equal TXY, TZX equal TXZ. So we can measure only this 6 component. Also, the TXX, TYY, TZZ, we can use this equation. So we don't need to measure the TZZ. So 5 component is enough. So usually this 5 component is measured. So this is a full tensor gravity gradiometry measurement. So it's called air FTG, full tensor gravity gradiometry. So this is an example of the signal of the gravity gradiometer. So when we conduct a gravity survey, so we can get only one gravity anomaly. So we can, it's easy to imagine the underground structure from the gravity anomaly. But from this gravity gradiometry component, so it's difficult to imagine the underground structure. So we need to conduct a gravity density distribution inversion from this component. So this is a comparison between the gravity and gradiometry. So the merit of gradiometry is we can get a very sharp signal we can get. So, but the merit is we cannot detect a very deeper part. So usually this gravity gradiometry is 2,000 meter or 3,000 meter depths we can detect, but more deeper part, so it's difficult to detect the underground structure. So this is a flow of the modeling. So using this component, so we will use some inversion code. Then we can get the distribution of the density and in the underground. So the next is the data processing. So when we get the data, so we need to data processing. So the observed gravity includes the many effects. So elevation, latitude, topography, and so on. So in order to reveal the signature in the gravity field caused by anomalous density structures, so this effect must be removed. So after removing this effect, so we can get a gravity anomaly. So usually we use a Bouguer anomaly. So the concept of the gravity anomaly means the difference between the observed gravity and gravity caused by the homogeneous Earth with constant density rho. So this part calculate the homogeneous Earth with constant rho. So this component is consists of the normal gravity, Fourier, Bouguer anomaly, Bouguer correction, and terrain correction. So at first, we get the data at the ground surface at the point P. Normal gravity calculate the gravity at the reference point. So this is height is elevation is 0 meter. So just same as a sea level. So this is a normal gravity. And then we need to correct to the ground surface. So we need to correct the height. So we can we conduct a free air correction. But so this correction, so between P and P dash is empty. There is no rocks between these 2 points. So we fill the rock with a density low. This is a Bouguer correction. So sometimes we use this shape or infinite slab. So the equation is different, but the result of calculation is almost same. Maybe the difference is a few micrograms. Maybe we can use the simple one. But after the Bouguer correction, so this part and this part, so this part has not corrected. So this part actually empty, but filled with rock. So we need to correct this empty part and not corrected area using topography data. So this is a terrain correction. So this is a calculation of normal gravity. So we can get using this equation. A little complicated, but almost is constant. So when we give the latitude, so we can get normal gravity. So it's very simple calculation. You can calculate in the Excel. And the Fourier correction, so we use the vertical gravity gradient. So usually the average in Earth, 0.3086 is used. But sometimes we measure this gravity gradient and multiply the elevation, so we can get Fourier correction. And Bouguer correction, so I show the equation. So it's very simple equation, but we need the Bouguer density, so assumed density. So this density is the average density near surface area. And we need also elevation. And the topography terrain data. So currently we can use a digital elevation model. So using this digital elevation model, so we assume like this topography, and we can calculate the effect of each prism using this. So we integrate all of this prism so we can get the terrain correction. So this calculation it takes very long time, but program will be calculated, so it's very easy. And for the Bouguer density, so there are many methods to estimate. So today I don't have enough time, so I will skip this part. So using the observed data, so we can estimate. Also, from the surface geology, and so there are many previous research about the density measurement. So using these data, so we assume the surface density. So after the correction, we can get the gravity anomaly. So the just like Bouguer anomaly. So from the Bouguer anomaly, so we can find the high anomaly, low anomaly, and the steep anomaly change area. For the geothermal survey, so we need to find a fault. So because around the fault, there are many fractures. So these fractures become water flow path, hot water flow path, or become a reservoir. So we need to detect here. So this is an important role of the gravity measurement. So this fault area indicates that this steep gravity change area. So to get the steep gravity change area, so some filtering is conducted. So this filtering is emphasize this steep gravity change. So for example, so there is like this structure. So here is the fault. So we need to detect here. So if we use the horizontal derivative, so we can get a peak just above this steep anomaly area. So from this maximum value, so we can detect, so there is a fault. But from this filtering, we cannot get how much this fault is a difference between the height difference directly. So another one is a vertical derivative. So we can get two peaks. So at here and here. So between these two peaks, so the crossing zero indicates the fault. So this is an example. So this is a Bouguer anomaly in Fukuoka, so in our hometown, center of the Fukuoka. So in center of Fukuoka, there is one big active fault is existing. And you can see here, the color is changed from green color to blue color. So this is the location of the active fault. So when we apply the horizontal derivative, so you can see the white color. This one is indicates this peak. So this indicates the location of the active fault. Also, this one is a vertical derivative. So you can see the border of the black color and the light gray color is a zero value. So the location of the fault. So we can know the location of the active fault. But it's difficult to how much the gap is existing. So to estimate the gap, so we need to make a model. So there are two methods for the modeling. So one is estimate between the basement rock and the sediments. So we can estimate the border of these two layers. So we call two-layer model. And the other is estimate the distribution of the density like this. So this is a cross section. So the low density area and high density area. So we need to set the model. So when we detect the active fault, so we usually use a two-layer model, like Fukuoka City. And in geothermal area, so there are many intrusive rocks, and so or fault or old volcanic rocks. So we need to use like this voxel model. So I will introduce the gravity survey application. So I will introduce the example of the Beppu area. So Beppu is a famous of the hot spring resort in Japan. And Beppu is located in Kyushu Island and the eastern part of Kyushu Island. So this is the geology of the Beppu area. So there are many volcanoes is located. So the in here, so the old volcano is located eastern part, and when we go to west, so the age is getting younger. So the Mount Garandake and Mount Tsurumidake is an active volcano. And so there are some fault is estimated by the geological data. In the northern part, so the Kannawa fault. The southern part is the Asamigawa fault. So Asamigawa fault is an active volcano, active fault. So this is a result of the Bugge anomaly. So we can see the northern part and southern part is very high, and so center part is a little low. So this including the wide area, regional geology is reflected. So this area, northern part and the southern part, so there is a granite. And the center part, the granite is very deep. So we remove this torrent, regional torrent, so we can get this local gravity anomaly. So you can see the steep gravity change here. So just corresponding to the fault location. But the northern part, the shape of the Bugge anomaly is not corresponding to the fault shape. So using, so this is a filtering. So this is a horizontal derivative from the local anomaly. So we can see here, so we can see the fault structure, but we cannot see in the northern part. And so to make clear this torrent, so we also use the improved normalized horizontal tilt angle. So this is a kind of the horizontal derivative. So we can see the different torrent around here and here. So in a horizontal derivative, it is difficult to see like this structure, but we can get around here structure, we can get clear. So currently we use this improved normalized horizontal tilt angle. So using this data, so we estimate the shape of the basement rock So this is a result of the basement rock. So the red color shows the basement rock located shallower, and blue color is located deeper. So we can see the fault structure around here. And here is some intrusive structure we can see. So this is a comparison between the shape of the basement rock and the temperature in underground hot spring temperature. So we can see the high temperature, so 200 degrees Celsius, is located along the this fault, Asamigawa fault. So in the southern part, the hot spring water is flowing along the fault. But the northern part, so the high temperature is located surrounding this intrusive structure. So this is a cross section of the south to east, north-south cross section. So we can see the fault structure in the southern part, Asamigawa Danso, or we can see the very clearly. But the northern part, the intrusive structure, we can see. So from this result, the hot spring structure is different in the southern part and the northern part. So, like this information we can get from the gravity survey. And so next is a gravity gradiometry. So I will use this component. So if we assume the very simple model, so from this prism model, so we can get like this signal of the gravity gradiometry data. So especially the vertical component, so the very sharp anomaly we can get compared with the gravity. So this is a merit of the gravity gradiometry. But it's difficult to imagine from this data to this model. So the advantage of, so this is a AGG, a little different instrument, but basically same as FTG. So the merit of the AGG and FTG, so we can get a dense data. So the line interval is 200 meter, but we can get the line direction, so we can get 3 meter. Every 3 meter we can get for the line direction. And uniformity. So we can get the distribution of sharp gravity and vertical derivative. So new possibility of geothermal exploitation we can do. So, but AGG data or FTG data does not include a long wavelength anomaly that is caused by the deep underground structure. So we need to combine this data with gravity data. So, but it is suitable to detect the underground structure at a depth of 2,000 to 3,000 meters, just same depth of geothermal reservoir. So this is one of the instruments. So this is a AGG, a little compact compared with the FTG. So AGG can use by helicopter, but the FTG cannot use by helicopter. So if we use FTG instrument, so we need to carry by airplane. And so this is a unit, so but I will skip this one. So this is a result of, so Japanese government conducted the gradiometry survey in the southern part of Kyushu area. So in the Kirishima volcano. So you can see the some vertical line and the lateral line. So this is a survey line. So I modeled this area using this data. This is a geology. The surface geology, so the many volcanic activity covered by the area. And it's difficult to see the fault structure, but estimated this direction fault. This is a signal of the 6 component. Using this 6 component, so I estimated the density distribution using boxy earth modeling, Geosoft. This is a result. So the this one indicates the high density areas. So there are many like this intrusive structure below the volcanic area. And this is a low density valley area. So this low density area is corresponding to the geothermal reservoir partly, a northern part, and this part is corresponding to the geothermal reservoir. So if I compare with the temperature and this density, so the color map indicates the density. So the red color indicates high density, blue color indicates low density. And the red line indicates the temperature of the reservoir. So you can see the high temperature area is located in a low density area here and here. So here, the Ogiri geothermal power plant is located here. So the Ogiri geothermal power plant, geothermal reservoir is located here. So this is a distribution of the pressure. So you can see the dense line area. So this area is interpreted as a impermeable zone. So this impermeable zone is corresponding to the high density. So this structure is divided the northern part and southern part reservoir. This is a summary. So the gravity survey can conduct in a few minutes with small working area, and not only a geothermal area, but also in an urban area. So dense microgravity survey is effective method to detect small structure such as a fault with become hot water, pass or the reservoir. When we understand the hydrothermal system, it is important to integrate the result of not only gravity, but also the MT, seismic, and so many geological and geochemical data using a GIS. Okay, so that's all. I'm sorry, so it takes a very long time. Thank you.
Thank you, Nishijima Sensei, for the engaging presentation about the gravity. And so for this session, we still have one speaker. Thank you for all of the audience and the online participant for the attention until this time. For the third presenter, I will give a brief introduction to Pak Udi. Yeah, Udi ya. Please show us the CV from Pak Udi. Yeah, the third presenter is Dr. Udi Harmoko. He is one of the staff lecturer from Geophysics Laboratory Undip. For the educational background, Pak Udi also attended doctorate in Kyushu University, ya Pak ya, from Earth Resource Engineering Department. And the area of expertise is geothermal scientist focusing on shallow subsurface resource exploration. For the research and publication, we have the aquifer zone delineation using correlation between microtremor models and geoelectricity, and proposed model of gathering system optimization on unit G4 geothermal power plant. This is only some example of his research. So, Pak Udi, are you ready for the presentation? Yeah, please. This is your equipment and your microphone. Time is yours for the microphone.
Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. And Ohayo gozaimasu. Kyushu University, Kyushu Daingaku no Gasei. Watashi wa Harumoko Udi. Yoroshiku oneshimasu. Mai wa watashi wa Niseng Sanenkara, Niseng Roke Madeni, Kyushu Daingaku de Sta. Just私は日本語で好きですけど、でもできません。Ladies and gentlemen, and thank you very much, Prof. Agus and Honorable Nistima Sensei, Indra Sensei, and all of participants in Zoom or offline on both of Zoom and offline. Actually, my presentation will be short presentation because it is my actually this method of magnetic methods I didn't use for many survey, but I just start from about this year because we have this equipment. We have equipment in this year, and we want to apply this method to use this equipment. And my talk will be spread as 5 term. First, maybe small introduction, and then general term of magnetic method, application of magnetic method on geothermal, especially geothermal, especially on geothermal system, and then processing, how to small processing in magnetic data, and some of magnetic field observation to prepare tomorrow workshop. Yeah, then maybe I want to introduce in the equipments, maybe. Yeah. As we know that geophysics area, we can observe on the Earth, and it is can divided by geo is Earth and physics is on the application of physics concept. Then we can use this physical properties of Earth, and then we can use many methods such as georadar, seismic, and then potential, also magnetic, and for of course this method will be used to identify for how the subsurface content or characteristic of subsurface system. And then to apply this method, we can many opportunity to study the physical properties of rocks, and we use the specific physical method. First, all data can be processed by computer, then it will be simple one. Then the aim of the geophysical measurements, as we know that generally we want to know such layering and discontinuity to part. And then and the previous interesting lecture from Prof. Agus and Nisima Sensei, that it's very clear that the geophysical, especially by gravity and gravity I forgot. CG3, yeah. Yeah, 6, yeah. Also can view what in the subsurface in communities, it's very clear. So that it's compare with if we have to know the subsurface by drill, the cost will be very cheaper. Yeah. Then let's start from the magnetic measurement. Yeah. Actually, magnetic measurement is is a geophysical technique that detects variations in the Earth magnetic field caused by subsurface rocks. Of course, by magnetic measurement, we can get the contrast susceptibility, and then this variation we can call as magnetic anomalies. These magnetic anomalies can reveal important geological structure, such as faults, and then intrusions, rock, and alteration zone, often associated with geothermal system. Of course, we know the geothermal system is composed from many kind of rocks and temperature, geothermal gradient and contrast of density and so on. So what is the source of magnetic signal? The primary source of the magnetic signal is the Earth's main geomagnetic field. It's generated by convection of molten iron in the outer core. Then this superimpose on the field are local variations which are caused by magnetic properties of crustal rocks. So that this local variation of magnetic survey are designed to measure. Then it is easy to and not heavy to do this survey. The Earth magnetic field consists of 3 parts. Yeah, there are main field. This influence of the Earth's main magnetic field is this, and this field is about 99%, and its variations over time is very slow and small. And then the next is external field and magnetic field anomaly. The external field comes from the ionization of atmosphere that's carried on by ultraviolet or UV rays from the sun, results in external impacts on Earth. Yes, which this impact create the external field. Variation of the magnetic field happen considerably more quickly in time because this external source is connected to the electric current that flows in the atmosphere in ionized layer. Yeah. Then the end, the third one is magnetic field anomaly. Yeah. This magnetic field anomaly measured on the Earth's surface are the target of our survey. Yeah, this variation. Yeah. So we have the magnetic anomaly, and then we can interpret this anomaly to be the target one. Yeah. Okay, if we see a little deep about the main field, yeah. The main field of magnetic fields is average magnetic field of the Earth, which is calculated from long-term measurements and covers a very large area, more than 1 million square kilometers. It's the rings. Then, as we know, that the Earth's magnetic field is not constant, but it will be changed slowly over time. Then this change can occur due to processes within the Earth, such as convection currents in the core, mantle dynamics, and variation in the Earth rotation speed. Okay, the next one is the external field. Yeah. The Earth's external magnetic fields originates from ionization processes in the atmosphere caused by solar ultraviolet radiation. And because of this field is related to the electric currents in the ionized layer or ionosphere, then a change in the external magnetic field occur more rapidly than change in the main magnetic fields in the previous one. Okay. And then this change of electrical conductivity of magnetic atmospheric layer, it can be on 11 years cycle. So it's a little bit long. Yeah. And then another one is there are daily variations in 24 hours related to the solar tides and 25 hours related to lunar tides. Okay. Then the third one is we talk about the magnetic anomaly, which we want to observe and interpret in the later one. The magnetic anomaly is often referred as the local magnetic fields. Yeah. These magnetic fields generated by rock which containing magnetic minerals such as magnetite, titanomagnetite, and other located in the Earth's crust. Yeah. Near this Earth crust, there are small variations in the main field. Yeah. These variations are relatively constant over time and location, and are usually caused by differences in magnetic mineral content of surface rocks. Yeah. The magnitude of magnetic anomalies range about 1,000 to nanotesla gamma, but there are also anomalies more than 100,000 nanotesla. It's come from the magnetic deposit. Yeah. The magnetic anomaly measured in the survey combine induced magnetization and remanent magnetization. If both directions are the same, then the anomaly value becomes greater. Yeah. But if the direction of opposite, the anomaly values become inadequate. So when the Earth's magnetic fields will be interacts with rock, it will be induced this magnetization. Yeah. Then by the interaction of magnetic field with the earth material, the different rocks will be respond to differently depending on their mineral composition, especially the extent of magnetic mineral, such as magnetite, hematite, or pyrrhotite. So the results is that some rocks will be enhance the magnetic field, while other may reduce or distort. Then about the instrument or equipment to detect the magnetization, how sensors can detect the magnetic field. Yeah. As we know that magnetic instruments such as ppm or optical pumped magnetometers will be measured the intensity of magnetic field at each location. Yeah. And the sensor measures the overall field magnitudes, including local anomalies or earth-mean fields. Then subsurface structure, it can be directly mapped by taking numerous of measurement throughout a survey area. Yeah, then we have to make manage point as many as possible. Yeah. So the next we want to talk about the application of magnetic methods, especially for geothermal system. Actually, the magnetic methods is what's very ideal for geothermal energy. Yeah. So that this method usually used for the first time or for just to know as such as introduction as the preliminary survey. So that from the magnetic survey, it has to be continued by another survey like gravity, then magnetotelluric or CSRMT. It would be, but by these magnetic methods, we will get the cheaper of operational survey, so that sometimes it will be convenient. In the magnetic methods, generally for the intrusive bodies, the thermal veins will be rich of ferromagnetic mineral. That this mineral will be correspond to the magnetic very well. And then the ferromagnetic minerals in thermal system will lose their magnetic properties when they heated to temperatures approaching the Curie temperatures. This is 585 degrees C. The magnetic methods also can be used to detect for the geothermal manifestation, especially for the shallow of geothermal manifestation. And the law of susceptibility magnetic will correspond to the anomalies of geothermal manifestation. And fresh andesite breccia rock has the high susceptibility. It's also a rhyolite andesite rock, and andesite lava have also lower susceptibility. And limestones also has the lowest vulnerability, susceptibility. Sorry. Low susceptibility also of rocks also due to the alteration process. And the alteration process, as we know that it comes from the influence of the fluid, geothermal fluids atau hydrothermal fluids, so that we can detect the hydrothermal fluids from the lowest susceptibility. And this is some of the results of study in the Papandayan Mons. Yeah, it's just from some of the susceptibility of magnetic. Even it's not my results. We just conduct the magnetic fields, but we haven't to finish from the processing and interpretation. That we, I apologize, do not show our results yet. The next talk, I would like to present about the simples of how to process of the magnetic survey. Actually, the existence of magnetic anomalies causes of change of the Earth's total magnetic field. So that we have here HM, and then it's IGRF, then HV, and delta HT. Each of these will be representation of the, this is the magnetic survey, and this one is IGRF from the website calculation model, and then this is the delay magnetic, and this is the anomaly. We start from the international geomagnetic reference field, called as IGRF. This IGRF is commonly used as the mathematical representation of the Earth's primary magnetic field. This primary magnetic fields on planets' crust, ionosphere and magnetosphere also. Yeah. This value of the Earth's main magnetic field intensity agreed upon the International Magnetic Institution. That will be referred from the website from this. And this value comes from the model, which calculated by this formula. Each of this R is radial distance from Earth to center of the Earth, and then P is longitude and theta is latitude, and then L is maximum degree of spherical harmonic expansion. Usually use 13. Then for A is the radius of the Earth. And then this is one of the magnetic field total intensity, which as a contour. And then this is magnetic model for the field declination contour. And this is result from 2005. Actually, for the IGRF is will be updated at each 5 years, yeah, so that it's very not up to date. Then, as we mentioned before on the previous slide, the total magnetic anomaly can be found from the magnetic measured total magnetic in the field, and then we calculate by IGRF, and then the magnetic delay on the Q2 delay variations. This is to correct it, the data from the field survey. So it is very simple, and we can use we can separate it, the survey to be the base station, the rover station, so that we have two kind of data. The first data we got from the daily magnetic variation data, which we continuously record, will be on the spirit time. As we said, we can set for 5, 10, or 30 minutes. And it's depend on the battery. Yeah. If we want to do the survey for longer time, maybe better to make the spacing time to be longer one. But if we have enough time or batteries, then we can use as shorter as will be better. This is the simple concept of the daily variation processing. We have to make data acquisition in the base station on an earlier one before we start to observe in the rover one. So that, for example, if you want to start recording in the rover station, start from 6:30 or 7 a.m. So that we have to start the data recording at the base station 1 hour or 30 minutes before. For example, we can start from 6, and then we can stop this measurement together. It's no problem. From this data, we can start to process for the daily magnetic variation data. This total magnetic measurement at the base station, then we plot to as a graph in the horizontal axis. We plot for the measurement time, and the vertical one to be the total magnetic data. Yeah. And then from this data, we can see that will be to be a graph, and we have to observe the maximum and minimum data. From this data, we have to make divided by 2. This is as the basement well. This is the example of the measurement data of observation sites. Yeah. For example, we have 5 points, and each of points will be separated by an hour. Yeah. And between an hour on one and the end one, as it's depend on the observation points. Yeah. If the observation point not so have longer spacing distance, then we have more dense of the observation time. We can do to calculate the EGRF reference on the first step or the second step after to calculate for the daily variation. If we want to calculate and match the EGRF reference, we have to do this website. We have to access this website and then enter these points of observation. From here, we will get many many columns. That is such as of course the magnetic calculation, magnetic field model, and then the inclination and declination, and also we have another one. Sorry, I forgot. Okay. Next, from the result of the rover observation data, we have to make as the data correction. This is the time which correlate between the observation and the rover time, and we plot here, and from this we will get the separation value. Yeah, this is for example 5, or this year 6. Yeah? And this from this we can make in the upper of the base to be reduction value, and the lower side to be added in the results to correct as the result correction. For example, here we have 5 points and the previous mentioned, and this is the variation of the delay data. Okay, and the end of this presentation, I would like to talk about how we have to prepare for tomorrow field observation. Of course, as you know, for general observation, we have to prepare the field observation points, and then the next we have to know how to operate the magnetic equipment. Yes, actually, for preparing the field point observation is very easy, and I think all of you has ever this process, this step that we plot first the distribution points. It's depend on the target. The longer or the wider one of the distributions will be better, but for tomorrow morning it would be just how kilometers per. Oh yeah, it's about 2.5 kilometers. Yes, it's enough, yeah, for us to climb Gedong Songo, yeah, Gedong Songo area. Then from this, for base station, it's better to choose the area which is very rare of access from the civilian, or maybe this is from where is the convenient one, yeah. Then in the rover station, we can plot here, and then we can use some application mobile. You can use Avianza map, also GPX viewer, locus map, and locus map, or so and so on. Yeah, you can choose one of them. Then for the ppm, we have to use a couple of equipments. So that we can use in the base station, and the one for the one. This is, I would like to introduce what the ppm we have, and tomorrow morning we will be used in the survey. It's called as GPM 10 proton magnetometer. Yeah. This is made by PPM. Yeah. This PPM we can use for another for many kind of survey. For example, this is have can we enable to make the working magnitude acquisition. So that we can measure the observation by walking. Yeah, not have to stop in the station. But for tomorrow, we have used the simple one, so that we have to stop in each station. Then another one, this display of the observed magnetic field on the main console screen in real time. We have not to stop, but it will be changed gradually. This specification of the equipments. And yes, it's happened before. We have a mobile mode, then gradient mode, and base station mode. Yeah. The keyboard function just kind of like this, and each of this we have to operate. But for the simple operation for tomorrow rover station, we just run and enter only, B and A only. Yeah. But tomorrow maybe we can demonstrate how to set up the first time before we mobile. We move one point to another point station. After we power on and off, actually it will be spirited to be to operation. And the one we have to set up the BIOS view. And the second one we have to set up in the rover one. Yeah, and the BIOS view we have to attend this voltage. Yeah, this voltage status. Yeah. Usually the status of voltage it will be full on 12.3, yeah, or 12.3 or 0.13, yeah, or 0.13. Yeah. And then we have to set up the clock, and then another one, the name of observation data. And also this is important to set up the UTC, the time region. If we forget to set up this point, for example, we have to push the seven button. Thank you. We have to push the 7 button. Okay, then this is the step 2. This is another view after we've finished to set up the BIOS. Yeah, we set up the BIOS and then will automatically save, and then will be changed to this view. From here, we will start to the setting for can start from the testing or data view or transmission and system setting. Okay, I think it's enough. And this is this is Matsumoto Sensei, this name. Sensei. Yeah. Yeah, Fujino-san. Yeah, Fujino-san. And another one is Matsumoto. And this one, Agus Sensei also there. Nishijima Sensei. Mada wakaides. Kakuin. Okay, I think it's all. Thank you very much for your time. And
Okay, thank you, Pak Udi Harmoko, for the interesting presentation about magnetic method in geothermal exploration. Okay, ladies and gentlemen, now we've come to the Q&A session. We are welcoming you to ask the question or just give a comment, response, or discuss the material previously delivered by our three speakers in front. So we have approximately 30 minutes of time. If anyone has questions, the online participant as well, please feel free to raise your hand or virtual hands, and I'll call you on speak, please. The participant from Kyushu University, probably first. Just raise your hand. Okay, and from the physics department. Let's discuss more about the material. Yes, you can ask your question or just maybe give a comment or your opinion.
Silakan kalau ada pertanyaan, monggo.
Silakan nih yang ini geofisik semua kan?
Mungkin dari Mas Indra bisa mengawali pertanyaan.
Mas Indra, can you give your opinion, comment, or ask question?
Okay, it's okay. So, one question to Nishijima Sensei. So, the news technology was the for conducting a gravity method. Practical, I mean, is it for the practice, or only for monitoring, or is it also available for exploration? Because elaborate my question, because if is it the absolute measurement or relative measurement? Because if it's relative measurement, then we have a reference, right? And the reference will have the accuracy is not like 10 microgal, while the other superconducting has nano microgal. So what about the practical use for the superconducting?
Okay, thank you for your question. About the superconducting gravimeter, so that is a relative one. So unfortunately, it's difficult to use for the gravity survey. So currently, almost purpose is monitoring for the geothermal area and CCS or something. So if we for the monitoring, we don't need a reference value. But so if we want to use for the reference value, so the FG5 absolute gravimeter. So another type of our absolute gravimeter, not yellow one. So if you measure the 2 or 3 days, so the accuracy become a 2 or 3 microgal. So that is I think best resolution accuracy of the measurement.
Thank you for the answer. And
Maybe I have a question. Since I have questions sorry. uh, as you present before, the filtering of gravity, such kind of horizontal gradient or vertical gradient, so we can detect the fault structure. Is it right? But is it possible to adjust that is a normal fault or reverse fault from that results?
It's difficult question. So many researchers try to make a model. So sometimes so we can change the angle of the fault, so we can calculate the gravity anomaly. So when we compare with so which one is more suitable for the gravity anomaly, so maybe we can estimate so that fault is a normal or reverse, but maybe it's difficult. Yeah. So sometimes for the active fault survey, so some dense drilling is conducted. So the comparing with that result, drilling result and the graph result. So sometimes we can make a model of the reverse or normal form. But basically, it's difficult from the gravity.
It's difficult to detect that just this is a normal fall or reverse fall. Okay, thank you very much. And the second question from me, I want to discuss about gravity. We have limitation about equipment, since we don't have instrument gravity in here. Some student in my laboratory try to process gravity, but from satellite data.
Yes.
For example, GGM plus like that. So sometimes we have a problem for some correction from filtering. So do you have any experience for processing satellite gravity data?
Unfortunately, I don't have any experience about satellite gravity. So, but I have experience of the airborne or the gravity gradiometry data. But that's why it's difficult to correct the precise correction.
Okay, thank you. We're still waiting for the participant in this class. Maybe Mas Indra?
Have question to Pak Udi. Yeah. So, what do you think the effect of the terrain in the gravity measurement? Is it has a big impact? And then the second one, because from my research, this terrain, especially in volcanic area, it will impact so much in the reading. So it will become biased sometimes if we don't consider this terrain effect in the model. And sometimes also when we model, because in my model also result like very high, very like minus 0.5 or 0.1 magnetic susceptibility, which is it's unreal in the real condition. The maximum diamagnetic material is minus 0.0001 or minus 1 by 10 to the power of minus 5 or 4 maximum. So what actually happened? Is it effect of the remnant magnetization, or is it because of the processing error, something like that? Thank you.
Okay, thank you very much, Mas Indra. Yeah. Maybe you mean you asked about the magnetic survey? Yeah. Okay. Of course, for magnetic survey, there is effect of the terrain. Then therefore we have to make correction. One of it's called as the upward continuation or downward continuation. If you want to know the target survey for the shallow one, we can use the upward upward continuation. Or if we want to know the deeper one, we have to make a downward continuation. This correction is such kind we want to to make that our survey is in the shallow one. Then we have to helicopter view. For your cases of for the change of the results, I'm sorry, couldn't give a comment because I don't have so far for the experience about this.
Following question. So, is it a tricky one when we put the like we don't know how like how big how far we want to upward the model, because when we like put a higher value, then it's become kind of regional too much. But if the shallow, still the effect of terrain is there. Method to anticipate or to predict the right value to upward or down, to upward especially.
Yeah, yeah. Of course, we have to just trial and error. Yeah, we'll try from to upgrade and yeah, this is not so good reason. Yeah, if we just try and but we have to get the results. The relation with one of course such kind. Because as you know, the magnetic survey we have
Thank you, Pak Udi dan Mas Indra. And for the next question, we have from the online participant. This question is from Mr. Dandi, GDE. Yeah. He asked three questions. I think each is for every speakers here. The first question addressed to Pak Agus, I think based on the context, can SP measurements be utilized to distinguish the fluid flow characteristics between acidic and neutral condition, particularly within the recharge and discharge zones? Okay, Prof. Agus.
Okay, thank you. It's nice question, a good question from Mr. Dendi about SP. So particularly, SP cannot directly decide the fluid pattern should be combined with another methods. For example, in my case, we combine with seismic and SP. It's better also we combine with geochemistry observation. I think Mbak Jenian already know about the geochemistry. She is expert one about this. So I think acidic and neutral condition it's depend the geochemistry result, I think. Yeah.
Yeah,
So
I
should we
agree.
combine the geochemistry? Come on. Can
Yeah,
you
I
add?
agree with Prof. Agus because for the fluid geochemistry, usually we have to do the geochemistry survey. That is, it can be previous survey or together with the geophysical measurement.
Yeah. So I think combine between SP and then geochemistry, we can detect which is the recharge or discharge zone like that. Yeah. Thank you.
Thank you. The second question is addressed to Ma Sensei about FTG or full tensor gravity. To what extent is FTG data significant in geothermal exploration when operating in areas with highly variable topography, considering Indonesia's undulating terrain, such topographic effects contribute to data distortion? And if so, would conducting airborne FTG surveys still be capable of producing high-quality assets?
Okay, thank you for the question. So when the FTG and the AGG is conducting, so that they measures not only the FTG full tensor, but also the terrain data using a LiDAR. So they can get the very precise terrain model. So using this data, so they can conduct a very precise terrain correction. So it's possible to use in Indonesia. But to measure the fruit tensor, so the instrument is getting bigger. So we need to use the airplane. So maybe the height is usually 3,000 meters. So sometimes it's difficult to detect the short wavelengths, so the shallower signal. But in case of that, so we can use AGG. So AGG measures only two components, but the instrument is very compact, so we can use the helicopter. So when we use helicopter, so the helicopter can fly along the topography. So the height is about 120 meter. So very low altitude can fly. So in that case, so maybe helicopter is suitable. Okay, thank you very much.
Okay, thank you for the answers. And the third questions for Pak Udi, ya Pak. Okay, is there a correlation between the physical parameter of magnetic susceptibility and the type of alteration minerals formed, such as smectite or montmorillonite? Furthermore, does the quality of magnetic data tend to be influenced by external factors such as lightning activity and solar wind? And if so, what approaches can be applied to effectively reduce such effects? Please, Pak.
Thank you very much for the interesting questions. For the first one, maybe it relates for the geochemistry, and I don't have enough data for the change of susceptibility and alteration minerals. Yeah. And the second, so that sorry, I could not. Maybe Pak Agus can help me about the change of susceptibility and alteration minerals. Atau Janice, can you help me about this?
I didn't have enough experience in geophysical survey, Pak. Maybe. Okay,
Yeah,
Pak
thank you,
Yoga,
Pak Yoga.
please.
In the andesitic type of rock, there will be a lot of magnetite minerals. And when the magnetite altered by hot water, the magnetite will alter into something different, maybe hematite. So the alteration of the primary mineral into secondary mineral, of course, will influence the magnetic susceptibility of the whole rock. So we can use the susceptibility of magnetic to distinguish between the fresh rock and altered rock.
Thank you, Pak Yoga. Yeah. On the second part of questions, maybe I can give a comment that, of course, the quality of the magnetic data will be very correlate well with the existing of the electrical or some of the that's metals, yeah, for the metals materials, so that we have to be aware for the electrical wire from the PLN, for example. It's very high, a very high correlation with the data. And the second one, for the for there is influence of the external factors such as lighting activity or solar wind. Yes, of course, the solar wind will be corrected by using the daily data correction in the base station. Therefore, we conduct the observation in the base station for that. It's don't worry for this hints. Oh yeah. I think that's my comment. Thank you very much.
Thank you, Pak Yuda and Pak Udi. Sirs, for the next questions, we still have a question from the online participant from Mr. Muhammad Zikri Prayoga from Physics Department. The questions is about gravity and geomagnetic methods applied in artificially stimulated geothermal reservoirs. that utilize hot dry rock with minimal natural fluids by injecting surface water, as in the Fenton Hill project, USA. Maybe Nishijima-sensei can give us the answers.
Thank you for the question. Maybe this question about gravity monitoring. So today I talked about gravity survey. So if we measure the gravity many times at the same station, so we can get a gravity change. From the gravity change, we can estimate the underground mass change. So in our research, so we are conducting the gravity monitoring in some geothermal field. So that is a conventional type geothermal power plant. So when the production is started, so about 100 to 200 microgal gravity decrease are observed. So maybe in case of EGS, we can detect the signal of the injection. But sometimes EGS depth is getting deeper, so it may need to use the superconducting gravimeter. Okay, thank you.
Thank you, Nishijima-sensei. Pak Udi and Prof. Agus, do you have additional comments? Enough? Yeah, we're still waiting for the question from the audience in this room. The student of Prof. Agus, maybe? Oh yeah, please. You address the question to whom? Okay.
Okay, so thank you very much. So for the geothermal survey, we need to detect the three components: the heat source, water, and the structure. For the structure, so especially that structure is coming from fault or the edge of the intrusive rock. So that structure is easier to detect by gravity. And heat source and water and existing, so it's easier to detect by resistivity. So we will usually use. So for the heat source, so it's difficult to detect the heat source, but magnetic method is one of the good method. So usually use this method is currently used. Sometimes so added some option, but maybe it's enough to use this method. Thank you.
Sensei, so what's your name? Kelvin, okay, yeah. That's the answer. We have to do comprehensive studies with several methods to. Any next questions? Any question from the participant? Oh. I will conclude this session. from our three speakers, we have some conclusion. First is Ungaran volcano is a quaternary volcano with interesting geothermal feature, which we will visit tomorrow in the field trip, so we can prepare for on-site visit for best learning experience. And for geothermal exploration, we also utilize geophysical survey, as mentioned by Nishijima Sensei and Pak Udi. Two of the method to identify the geothermal system is gravity and geomagnetic to identify such a geothermal feature like structures, faults, intrusive bodies, or alteration rocks. And we can also practice to do the data acquisition in the field tomorrow. So prepare for the most and the more interesting learning experience tomorrow. Okay, ladies and gentlemen, I would like to, the last time, to say thank you to Nishijima Sensei, Prof. Agus, and Pak Udi for giving us a very insightful view about geothermal exploration. Please give applause for the presenter. And see you all later. Thank you very much for this honor, and over to you, MC.
Okay, so we just finished the Q&A session. So now we will be proceeding to the break session that will last for 1 hour. So we will be back in 12:24. Oh, I'm sorry. We will be back at 1 p.m. Hello everyone. How's the lunch today? I hope it's really good. It seems like the time has hit 1 p.m. So we're gonna continue to session 4 and session 5. That will take about 2 hours. I will now introduce the moderator for the session after the lunch break session, which is Pa Fahmi. Pa Fahmi will be the moderator for our 4th and 5th session. I will now hand over the mic to the moderator.
Oke. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone. So now we will have another session for summer course Geoexploration 2025. So we will have speakers from geological engineering from Diponegoro University. The name speaker is Mr. Yoga Ariwibowo. Okay, for Mr. Yoga have educational background as geological engineering from Gadjah Mada University for his bachelor degree and for master degree from ITB with the same topics, with the same subjects, geological engineering. And for Mr. Yoga, expertise in mineral geochemistry. So after this, we will discuss about the geochemistry with Mr. Yoga. Mr. Yoga, can you go up? Okay, so for the session itself, nanti we will have a presentation first from Mr. Yoga, and then after that we will continue to another session from another speaker, and then later on we will have a discussion session. So now Mr. Yoga will present about his topics. Mr. Yoga, are you ready? Okay, Mr. Yoga, time is yours.
Yeah, thank you very much, Mr. Fahmi. Good afternoon, everybody. I will try to explain the geology and geochemistry of the Ungaran geothermal system. And the data I use here is the data from 2014. Yeah, the last research I conducted with my student. So yeah, next. Next. Yeah. Yeah. This is the visual of Central Java, where lies in the northern part of Semeru Mountains. Indicated the volcanic, most recent volcanic activity in Central Java. So, and the volcanic is about 30 kilometers from Semarang, southward of Semarang. Yeah, I would like to compare structural pattern of the Ungaran and the Dieng geothermal system. You visit the geothermal system in Friday or Saturday, next Saturday. So you can compare of these two systems. Which one you visit tomorrow? If you see the scale here is the different scale. So the deep system is higher than the older system. The difference here is there is similarity of the circular structure outside the system, but the is consists of this is caldera that several broken new crater. So of new craters make the geothermal system here more complex rather than the home system. The system is so structural, maybe on some system here that control the activity at the southern part, at the eastern part, and the northern part of the volcano. This is the southern flank of the Ungaran from the southern. We can see here the of the structure that associated with the occurrence of the geothermal manifestation. The geothermal manifestation, the most active geothermal manifestation occur here. You will visit tomorrow, and you can see what kind of the surface manifestation that occur here tomorrow. This is the of the volcanic product from the volcanic activity is lies underlying the sedimental rock. The old Pleistocene deposit, the marl series consists of tufaceous marl and tufaceous sandstone. So the basement of the volcanic is the sedimentary rock. Mostly have characteristic of the volcanic activity in the form of tuff. Yeah. So, but it is the sedimentary rock consists of volcanic duct or tuff. The older Ungaran, we call it notable refleksi. is the oldest product of Ungaran, and we can, yeah, the oldest Ungaran product as a fragment, a basaltic fragment of the Brixia. And the second cycle of the Ungaran volcanic activity we of the Ungaran volcanic depth is relatively more andesitic, or the silica content is relatively higher than the older. Yeah. Yeah, this is the stage of the Ungaran volcanic development. The initial process is formed in lower Pleistocene, formed the Damar bed, the sedimentary rock, the volcanic, all this volcanic duct of Ungaran. In the middle Pleistocene, the first Ungaran duct overlying the Damar bed, and the young Ungaran is active from upper Pleistocene to Holocene. Yeah, this is the geological map of the Ungaran volcano. We have the formation is alluvium, not exposed here. This is alluvium from raw opening, and there are several lava as central central facies product, and then brexia in the medial facies product. So the variation of the lithology is consist of lava and the site lava and the site brexia and the facies pyroclast. The occurrence of the surface thermal manifestation, mostly the most active manifestation here in the southern flank of the Ungaran volcanic. There are also exists in the southeast flank of the Ungaran volcanic, but the so there in Gedong Songo here in the southern part is exists some manifestation that indicating the high temperature, but in eastern or southeast part is the manifestation indicating the lower temperature, and the northern part or northwest part of the Ungaran volcanic also shows manifestation that indicating the manifestation here. This is the andesite outcrop near the Gedong Songo area. In the northern part of the Gedong Songo area, it indicated that the central facies or the primary activity of the volcano around the Gedong Songo area. And this is the photomic micrograph of the andesite. You can see that the mineral predominantly with the plagioclase, and the plagioclase is relatively in the neutral range, but andesine and oligoclase. And the mafic mineral that occur or identified are pyroxene here. This is the outcrop of the explosion of the pyroclastic activity. This is the pyroclastic deposit, and this is the pyroclastic volcanic breccia. It's mostly consists of the ash or the volcanic ash, and this breccia consists mostly of the andesite lithic or andesite class. We can also found the intrusion, but the intrusion in the southeast part of the Ungaran volcano is already identified as older than the Ungaran volcanic activity. So the andesite not related to the magmatic activity that formed the Ungaran is relatively older. Okay, I will explain a little about this chemical hydrological structure of geothermal system by Hedenkis, 1985. As we know that geothermal system controlled by several type of fluid. The first fluid is magmatic fluid. It is the crystallization is here, and characteristic or chemical characteristic of this magmatic fluid is there are, of course, H2O as a solvent, carbon dioxide, and acid chloride, and acid fluid, and SO2. This compound characterize the magnetic fluid, and the temperature of the magnetic fluid about less than 500 to 400 Celsius, and magnetic fluid will rise, and somewhere the magnetic fluid will mix with the meteoric water recharge that colder. The interaction between the magnetic fluid that hot and the meteoric water that relatively cool will form the geothermal fluid here that accumulated in the pore of the reservoir, we called it. The result from the magnetic fluid interacted with meteoric water will accumulated in the reservoir on the temperature relatively slightly lower than the magnetic fluid. So the temperature here will be lower than 400 to 200, maybe 250. And somewhere here, when the pressure and temperature reach at the certain condition, it will be hot, and the process separated between and the gas of vapor. So there are some constituent or some compound that altered from liquid into gas or vapor phase. So water and hydrogen sulfide will is because under 30 under 300 Celsius, the dioxide and hydrogen sulfide will altered into gas phase. But the Na natrium sodium chloride altered into gas phase because the chloride above 400 Celsius, and when the process is below 400, so the sodium chloride will stay at the reservoir. That's why the reservoir the existence of the anion of chloride here. The water, the carbon dioxide, and hydrogen sulfide that rise somehow will be cooled down when they go up. So after the alteration from liquid to vapor or to gas, they will first to be liquid again. So we can call it the condensation phase. So the condensation will take place in two different conditions. One, the condensation will take place in the below the water table, and the other, the condensation will happen up of the water table. The condensation below the water table mostly influenced by CO2, and the condensate will be characterized by the abundance of the bicarbonate, because the reaction here below the water's table will be CO2 or carbon dioxide. And the process above the water table will be influenced by the existence of the oxygen at the pore of the rocks. So the oxygen that exists at the pore of the rock above the water table will react with the hydrogen sulfide to make compound acid chloride. So the water that form above the water table will be acid sulfate. The bicarbonate below the water table and acid sulfate above the water table will then migrate it, because the acid sulfate relatively shallower. So the migration of this kind or this type of water, condensate water, will relatively be vertical, because not too far from the surface. But the bicarbonate water below the water table will migrate laterally or horizontally. So the bicarbonate water will occur relatively more far away than the acid sulfate. The acid sulfate rise relatively vertically. So the movement of the acid water will be vertical, and the interaction between acid water, acid hot water, and the rocks will create the alteration of the rock here intensively. So the characteristic of the up or upflow zone will be acid spring, acid hot spring, or acid warm spring, and also associated with the alteration, surface alteration that mostly from will alter the andesitic rock into secondary that mostly consists of clay mineral, yeah, or other mineral that acidity, low acidity. So there are another feature or surface feature that can be considered as a marker of the existence of the reservoir is fumarole. Fumarole is direct outlet from the reservoir of the vapor from the reservoir. So we can use the existence of the fumarole and acid water as indicator of the upflow zone, and the existence of the bicarbonate water is a mark of the lateral outflow zone. This is a surface manifestation that we can find in Gedong Songo. There are relatively mud is mud here is the result from the water or acid water, acid sulfate water interact with the rock here. So the result is the mud or fine grain secondary mineral. There are also excess of the fumarole, so we can consider that the existence of the fumarole and associated with relatively acid manifestation is indicator that this area is the flow zone. This is the older non-active manifestation. There are no active fluid circulation here or fluid activity here, but we can see here that the alteration of the rock from the fresh andesite altered into relatively dominance by the clay minerals, clay secondary mineral, is indicator that previously here are so many fluid activity, mainly acid sulfate fluid. And the secondary mineral that have identified from this area indicate that the water that interact with the rock is have low acidity. So the alunite, kaolinite, halloysite, cristobalite, and amorph silica indicate that acid water interact and leach the previous primary rock and alter the rock into the secondary type that change in color, change in hardness, change in physical properties, also change in chemical properties. This is the surface manifestation at the southeast or east part of the or east flank of the Ungaran geothermal system. We can find several warm and hot spring there, and the characteristic is relatively bicarbonate. As I said before, that bicarbonate water is indicator or the marker of the lateral movement of the water from the system, from upper of the system, from below water level to the lateral part of the Ungaran. This is chemical analysis from several type of the water we collect at the Ungaran system. This first tree is taken from southern part of the Ungaran, or Kendali, or sorry, Gedong Songo, and the water relatively consists dominant by sulfate water. You can see here the bicarbonate 0, chloride less than 1 ppm, but the sulfate is relatively high here. So this type of water is sulfate water. That indicator derived from the condensate that form above the water table. The sorry. The other water sample show that mostly is the bicarbonate. The anion dominant here is bicarbonate, so we can consider that this type of surface manifestation is the lateral product of the water distribution here. From this ternary, we can see that there are no chloride water identified here. So there are no water that directly come from a reservoir that we can found at the surface. Most of the surface water is here in bicarbonate edge, and some of there are 2 or 3 is mixing between chloride and bicarbonate. Some of the water also mixing between sulfate and bicarbonate. So we have no proof, or we have no tools to indicate the condition of physical or chemical condition of the reservoir, because most of the water that occur at the surface is not come from reservoir directly. And the ternary, cation ternary, we can see that most water is immature or not represent the reservoir. Only one is relatively partially equilibrium. So this we cannot use the water sample to interpret the reservoir condition. So how could we predict the reservoir temperature? We use the gas sample, not the water. Yeah. We collect the sample of the gas from the fumarole and we analyze, and then the result is you can see that, and from the CO2 and H2 we calculate the geothermometer, and the temperature predicted from the gas geothermometer is about 230, 200, yeah, more or less 230 Celsius. From the CO2, H2, and AR diagram, we also can infer that the predicted temperature of the reservoir is slightly below 300 or about 285 degrees Celsius. And last, from the surface chemical data, we can make a geochemical model of the geochemical model. That there are some body of rock that relatively porous, filled by water, and at the depth about 1 to 2 kilometers, there happened the boiling phase, and the condensation happened here to make the acid sulfate water that migrate directly to the surface. And we can see the evidence is acid sulfate spring and also fumarole here. And the condensation below the water table will migrate laterally and occur at the northern part of the Ungaran flank in Nglimut. You will not go there. Maybe you only go to the most active manifestation area in Gedong Songo. So the recharge come from the outside of the Ungaran main body, and then interacted with the magmatic water here and to accumulate here somewhere in the reservoir. Arigatou gozaimasu. Thank you.
Okay, so that one, the presentation from Mr. Yoga about overview geology and geochemical in Gedong Songo, in Ungaran, and also in Dieng. So because Mr. Yoga have limited time, so I will open for the question and session. So if you have any question, please ask your question. Maybe I will open for the first session is for 3 question first. So have you have any question? Okay, the first one from Mr. Udi.
Okay, very interesting presentation. Thank you, Yuka Sensei. I have a question. You mentioned that Kendari Sodo has an underside intrusion, and also you said that this intrusion not related to the volcanic Ungaran. Is it? Could you please explain more about this? And are there any scientific clue that the Kendari Sodo this other manifestation is not related to the volcanic Ungaran? Thank you.
Okay, thank you, Mr. Udi. Yeah, there are some investigation about Kendali Sodo intrusion, and the dating state that relatively far older than even the oldest Ungaran or Ungaran. So from the dating investigation, it could be concluded that the Kendali Sodo is older than Ungaran. The alteration and the occurrence of the surface manifestation there in Kendali Sodo is related to, I mean, the thing that not related is the intrusion activity, but the occurrence of the manifestation is related because the source of the water, of course, came from the recent geothermal activity. So the thing that not related is the intrusion process, because the Kendali Sodo is far older than Ungaran volcanic activity, but the hydrothermal process, the water circulation is migrate to the Kendali Sodo area. So the surface manifestation in Kendali Sodo area is related to the Ungaran geothermal system. Yeah.
Thank you very much for the answer, Mr. Yoga. So still have to a lot for a question. So is there any one of you want to ask about geology and geochemical to Mr. Yoga? Or if in the Zoom, if there is any question, you can write the question in the chat box. So I will read the question. Okay, so as I mentioned before, Mr. Yoga have a limited time. So after this session is finished, Mr. Yoga will not join again. So if you have any question, you can ask now, yeah. Okay, so I will try to read the question, yeah. So from Dandi Baskoro, if I'm not wrong, based on the CISO4 HCO2 ternary diagram, there is a manifestation sample classified as a sulfate water, represented by a blue circle that indicates a cold type manifestation. If I'm not mistaken, does the blue symbol represent the temperature, Or so, why can the sulfate content be high?
Can we go back to the ternary slide?
Maybe for the operator can help to share screen about Mr. Yoga's slide presentation.
Circle is in right represent the cold water. So because we not only analyze the warm or hot water, but also the cold water. Circle that placed into the sulfate water, you can see the composition of the uh, sulfate not really high, only 72 ppm. If we compare with another constituent or another anion is much lower. The other unknown is much lower. So the type, the type of the water is referred to the dominance of the sulfate compound here. But the concentration is not relatively high. But why the sulfate is dominance here compared to the another anion? Because the occurrence of the Dasamuka spring or cold spring is also near the Dasamuka hot spring here. So it could be influenced by the acid sulfate from condensate water from acid sulfate water. But this type is cold water or relatively much shallower water. And the shallower cold water is influenced by some part of the acid sulfate water.
Okay, thank you, Mr. Yoga. So, in this room, there is any question, maybe from Kyushu University? You can ask a question to Mr. Yoga about geology and geochemistry in Ungaran and Dieng Mounds, or anyone from other participants. Okay.
Thank you. There are some similar case that occur in Dieng regarding to the high silica content. And high silica content there related to the relatively acid water. So as we know that acid water have a corrosive properties. So the more acid, the interaction between fluid and rock will be very intense, and very intense interaction between fluid and water will result in the high silica content because rock or volcanic rock mostly mostly consists of silica, more about 50 to 60 silica, right? So if the leaching or the leaching from the acid water more intense, so the silica content will be more intense. There are study regarding to the silica content here. Of course, it will have a negative impact to the production. The scaling at the what is it? At the reservoir itself, it will be the permeability will be lower and decrease. Also, at the pipe distribution pipe, so the diameter of the pipe will be also decrease, and the vapor production will be decreased. So there are some study about the water treatment because silica not only silica at the water product produced by geothermal activity. There are also some chemical constituents. We can use and the study, but it's in Kyushu University. Some of the product, including silica, is processed into fertility material to yeah. So the water that have separated injected into the system will have a lower silica content. That's what I know. Hopefully, answer your question.
Okay, that's all for this fourth session about geology and geochemical from Mr. Yoga. Thank you very much, Mr. Yoga, for your time and your presentation. Okay, so we will next to the next session. Okay, we will next to the session 5, which is we have another speakers from BIN. So our next speakers is Mr. Agustia Ardimarta. Now his position as Chief of Research Group for Disaster Technology and Enhanced Water Energy Potential. Okay, for his company organization is from BRIN. So for educational background, yeah, for diplomatry from AMG, and then bachelor degree from University of Attahiria, and then next to master degree at FTTM ITB, and for his doctoral degree from ITB at FETB. For the Mr. Agustia, area of expertise in earth science exploration, especially for geothermal, oil and gas, and also mineral. Mr. Agustia will present about application of passive seismic in geothermal system, right? Okay, so Mr. Agustia, for time and place is yours. You can start your presentation.
Thank you very much. Hello, everybody. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
My name is Agustia Dimarta. Before join to Research and Innovation Agency, I am from BMKG, Meteorology and Geophysics Agency. So, present my presentation about passive seismic. I will present my presentation about the passive seismic for geothermal exploration. Actually, passive seismic is not only for geothermal. Usually, we use the passive seismic method for oil and gas, mineral, coal, and another or civil engineering also. This I will present our research that conduct by some company, not only print but another company like Pertamina, Geodipa, and another. Passive seismic. So when we use it, I will introduce our seismograph. This is SRI. We call it SRI, SRI. It's Seismograph Rakyat Indonesia or Indonesian Seismograph. This is our seismograph. And then, this is our seismograph, 3 component. And then it can portable or it can be used for monitoring, real-time monitoring. And then another seismograph, we usually use the Smart Solo. Maybe from our friend from Japan know, but the Smart Solo it's good seismograph. It's a product by Chinese. And then this is the Lenat. Lenat is production from Germany. This is the Lenat. This is my first experience when we deploy for geothermal exploration. We use the Smart Solo maybe in 10 years ago. And now we use the Smart Solo and use our own seismograph, SRI. Actually, when we deploy seismograph 3 component, we can produce the result from micro earthquake. The first. The second, we can use the information subsurface about using the method of VSR or Nakamura method, and then ambient noise tomography, and then the spatial autocorrelation. And the new method is time reverse modeling. We use time reverse modeling is for for imaging, for identify the oil and gas in some area, collaborate with Pertamina, and then we can for AVSR, for Nakamura or AVSR method, maybe tomorrow we will not tomorrow. I think Ali have conduct some survey in Gedong Songo, yeah, in Gedong Songo yesterday. HVSR, it's a simple method. We can use actually in BMKG we use HVSR for mapping, geotechnical mapping. But now we try to compare HVSR to find the water. For find the water, oil and gas, coal. Actually, Ali maybe 3 weeks ago go to Peru to exploration, coal exploration using the HVSR, and they have compared by aeromagnetic and gravity also. Yeah. HVSR, we can produce the HVSR only use the 15 minutes until 45 minute data waveform seismic. So it's short time for waveform seismic processing, but we need 3 components. And then subsurface imaging we can reach until 500 meter. It depends on your model parameter. And then for geothermal, we just delimited by deep. Only we can get the information of caprock identification. It's so hard if we can get the reservoir or heat source geothermal. And then the others, we can use the HVSR method. Information is for rock hardness level. To plan, actually you can use this information for the infrastructure planning for geothermal power plant. And then the other method is ambient tomography. The ambient tomography is have little more long than HVSR. But the ambient tomography is a promising method that can combine with the magnetotelluric. Maybe it's usually in geothermal we use the gravity or magnetotelluric. No, in Indonesia we have started to use the ambient tomography or its geothermal field. In ambient tomography is a little bit different. If Nakamura or HVSR method using the 3 component, but the ambient tomography we just use the 1 component, vertical component, Z. And then we can reach imaging at the deep until 6 kilometer or 10 kilometer. And then we can get the information about reservoir or heat source information. And then the ambient tomography, we have to help some company to get the success well logging to get the reservoir geothermal in some field in the Sumatra. And then the last is the spatial autocorrelation. It's a little bit hard to get to conduct this method because we have to triangulation or the it have so little bit different than Nakamura and INT. In Spark, we use the data is 30 until 1 hours. 1 component, same with the ambient tomography, and then the tip depend on your regional station. You can, if you have 6 kilometer, you can get information until 5 kilometer. And to identify the Spark can identify the reservoir identification and its source also, and then it's we can get to help the well targeting. Actually, in micro earthquake, when you deploy ambient tomography acquisition or micro earthquake, you will get pointernya kelihatan ya. Usually, this is the waveform seismic in 1D. You can see how many earthquake in this D. It's usually happen in the geothermal field. It's just triggered by by earthquake with 5 magnitude. This in the Sarula field. It's Sarula Operation Limited in Sumatra, North Sumatra. This is only one day. There are 2,000 earthquake only one day. It's the magnitude is from 5 until 0.0, less than 1, but even. This is the earthquake, and then it can use the data is for identify the reservoir, to identify the reservoir or volcanic event, and then we can use this data for body wave tomography. I think Ali ever process the micro earthquake, or anybody process micro earthquake? If we use the manual processing, it's so hard because we have to send the information to the production, division is less than 1 hour. So I will introduce also our new product. We develop our Indonesian INASEIS, Indonesian seismology. This is for identify automatic picking for micro earthquake in the magnitude less than 1. And then we have compared to the manual acquisition, to the manual picking. And then this result is will used by Pertamina in this day, in these years. In these years, we get 2 locations to fill geothermal power plant to monitoring using the Indonesian processing software. We can get the information not only hypocenter, and we can get the until focal mechanism to identify the type of fault, normal fault or strike slip. And then the HVSR, we can use this. The HVSR is the simple method, but it's promising for geotechnical, for geothermal, and also for oil and gas. We have compared to geolistrik. This is the geolistrik itu apa? Resistivity method. In the top is resistivity method. So that's my point. The top is resistivity method, and then in the bottom is Nakamura method. It's inverse by using the Dinfer. This is the comparison. This is the same in the same line. This same line. You can use this. The low resistivity is equal with the low VS anomaly. And then this is we use the Nakamura method we use for identify the landslide area in the Flores. This is the new fields. Maybe in the next year it will new power plant in this area. It will built by DSS. This is using the just AVSR. This is the area, and then in AVSR also we can identify the location landslide potential in the geothermal area. And then ambient tomography, maybe in 10 years ago, I have challenged by Pertamina to apply the ambient tomography in this area, and then we get the low. Okay. We get the low anomaly. Low anomaly is equal VS. VS anomaly. Shear wave velocity. I call it shear wave velocity is VS. Yeah. VS, low VS. Low VS identic with the geothermal reservoir. after it, we can combine with the another method after it. And then another method is Nakamura method, or horizontal to vertical spectral ratio. This is the frequency dominant frequency in this area. And then when we plot, it's just frequency, dominant frequency. It's just about frequency dominant. It's the first result from this method. We can mapping the dacit. This is the fresh rock dacit. It's associated with the high frequency. So it's the right result. And then, but the taposbrexia is that associated with the clay cap or the sedimentary in this area. It's dominated by low frequency. And then, the volcanic lava is dominated by low and high frequency. And then in the northeast is dominated by low frequency also, and this is the sedimentary sediment. We can find in this area we find the clay cap in this area in the taposbrexia. And then when after it we can invert your ellipticity curve using the Denver software. It's free also. You can see that this is the manifestation. This is the manifestation area. The tool manifestation is dominated by low Vs. So after frequency, we get the silver velocity. This is the Vs. This is the manifestation. And then I will tell about the ambient noise tomography. Unstable again. Okay. Repeat imaging of quality based on seismograph network configuration. It's little bit different with body wave tomography. If body wave tomography, we depend on the earthquake, but we can conduct the earthquake. We just wait the earthquake. But in the ambient noise tomography, we can conduct the rigid of ray path. So we can get the good resolution for ambient noise tomography in this its area. Is we can compare with the body wave tomography method. We use the earthquake data. If we have just three, we just get the resolution just like this, the bad resolution. But if we use the ambient noise tomography, if we have the 6, maybe we will deploy this seismograph more than 1 weeks. But in this ray path of ambient noise tomography, this is the target area. We know where is the target. Target area is the first is we targeting the manifestation area. This is the seismograph. We can get the information from ray path, and then tomorrow we will change again. We will move the seismograph, replace the seismograph and install to another place. Yeah, another place. 3 days, 4 days, 5 days. Yeah, 5 days is enough. If we have 26 sensor, so we can install the all seismograph. This is the better than in the bottom ray path. Is noise seismic. Noise seismic is we use the ground roll activity from sea. But actually we can use the human activity like drilling. If the drilling is recorded by all seismograph. If just one seismograph record, we cannot use. You can see that is the simulation. This is the A, B, C station is different station. B and C is near, is close. The distance is about 500 meters far, I think. but in seismology is the distance is near. Now this is the earthquake. This is the earthquake. We can identify the earthquake, but earthquake is this is no earthquake. Earthquake, and this is just the waveform seismic. If we zoom, we can get it. We zoom it. We can get this waveform seismic, and then we can zoom again. Maybe the Alice and team data, you can do it also. This is the near seismograph. BC seismograph is a little bit equal than the C. It have a distance about 5 kilometers with A, but C, B and C is the distance is only 500 meters, 0.5 kilometers. It can this signal is can process by it's like delay time. Delay time is can give the information about the subsurface in the pair of the station. In ambient tomography, this is the first actually you can data acquisition, deploy the seismograph in the waveform in the field, and then the cross-check the portable seismograph, and then we can get the raw data, and we can combine with the permanent waveform from Meteorology and Geophysics Agency if there are seismic station in near this area, and then we can assessing the time shift in the waveform data, and then we can choose the single data preparation, just Z component, vertical component, so just one component, and then we can remove response instrument if we use the different seismograph. If we use the same seismograph, is we don't need this step. And then we can process the cross correlation, and you can get the group velocity, and then we can get the tomography subspace inversion in the group velocity, and then we can get the depth inversion, and then in the next we can do the interpretation. It is the instrumentation. We can use for ambient tomography, we can use only one component. Is the one component seismograph, or three component is better. Three component is better. And the first, we can check before we install the seismograph, we can check the quality of three component of the seismograph. Using the power spectrum density, we can do you know this method? Not yet. Maybe next you can learn from Ali. Power spectrum density is the first time, the first step to know the quality of the seismograph. This is the bed. This is the Peterson curve. It's called the Peterson curve. This is the good seismograph. This good condition. Then the seismograph, another three seismograph. Data acquisition, actually we have to overnight in the forest because the area of geothermal is so far from the village, or from the from the village, I think. Yeah, maybe 7 weeks usually in the remote area. Maybe just one night, maybe it depend on the area. You have to know, Ali, if overnight in the forest, Ali, in the burrow. Okay, yeah, it's a cool field. Maybe you can try in the geothermal field. In Sumatra, it's a little bit dangerous because the Sumatra tigers. So when we explore in this area, we have to company by polisi hutan itu apa? Forest police. Polisi hutan, forest police kali ya. Itu forest police. Because the Sumatra tiger is little bit apa ya? Imut ya. Little bit more dangerous than the Java tigers. But when you use it is a 1 month ago, we deploy the ambient tomography in Flores. But in the Flores is different mountain, different environment in the Sumatra. This is the little bit easy. So we don't need to overnight in the forest. And then in this area is no dangerous animal. But the area when maybe you can finish the install the seismograph easily, but when you uninstall, you can get the so hard location. You have to across the the river is it have surut apa surut? It have a little bit surut.
So the water not so much ya, Pak?
Yeah, not so much. So we can success. If the water is so big, so maybe we have to wait 1 week until we can cross safety, with safety. This is the cross correlation we have compared. Actually, maybe 5 years ago, 10 or 5 years ago, so many researchers or companies talk about our method because we just apply 1 days for cross correlation, and then we have compared the 1 days or 20 or 3 days is get the same cross correlation, the same quality. So I mean, so 1 day or 20 or 1 month is we can get the same result. So why we have to deploy for 30 days or 20 days? This is the monitoring quality. After we finish the one installation, one period of installation, we have to take a data, download the data, and then we can check using the simple method. The first is we use the Nakamura method to get the F0. If the area is clear for the frequency dominant, so it's good data. And then also we can process the short process using the cross correlation. If it's cross correlate, we can produce the cross correlation like that. So for the time being, we can continue our acquisition. This is the step, QC data, either an ambient tomography station. Maybe sometime we can, the coordinate information is wrong. So the data all is wrong. The first important of the geophysics is the coordinate. If the coordinate not good, so your data is not good also. The second is cross correlation, and then we can continue dispersion curve velocity until interpretation. This is the cross correlation. You can see if the like that the cross correlation is the good cross correlation. I think this is the cross correlation. We can get information. This is the good or not is if we can get the information like that is a good cross correlation. And then the dispersion curve. This is the dispersion curve. And then is the group velocity peaking. And then we can check the resolution test to get the information, the best parameter about the smoothing, damping, and grid resolution. This subspace inversion, this is the manifestation of the geothermal manifestation. It's the geothermal is in the area we can identify the contrast anomaly. We can identify this area is a fault. This is the ray path. And then after it, the group velocity we can compare with the micro earthquake result. This is the micro earthquake result. The micro earthquake result, if in this area, if the high velocity is close to low velocity. Low velocity is some structure that when triggered by some earthquake, maybe just magnitude 3, maybe usually the area will produce the earthquake, so many earthquake. It's just a trigger by one earthquake, so we can this area is get the so many earthquake in this area. It's begitu. This is the area. If we check the topography, this is the fault. This is the physiography, and then it's related with the epicenter in this area. Epicenter in this geothermal field. After it, we can produce the depth inversion using the Denver, same with Nakamura method or FVSR method. And then this is the interpretation. This is the interpretation of VS zero velocity in this geothermal field. This is the low velocity. This low velocity associated with the clay cap or cap rock. And then the high velocity is identified by fresh rock, but it is in the surface fresh rock. And then in the elevation of 0 meter elevation, this is the di atas MSL apa di atas MSL itu apa? Di atas bukan mean sea level, di bawahnya. Itulah ya.
Above
elevation ya.
Above mean sea level.
ASL. Oh, ya beginilah. Nah, in the elevation 6 meter, 10 meter, and then we continue to in the bottom in the 0 meter, minus 250. We can see that is the contrast structure is identified by fracture in the geothermal area. And then in this area is in the minus 1,250 meters is the subsurface structure is equal with the location of hypocenter. This is the cross correlation of this area. This is we combine with the hypocenter of this area. This is the contrast anomaly is identified with the fault identified. This is the fault and it's equal with the hypocenter even. And then the next we can in this area, in this geothermal system, we have the information, the well prognosis of this area. We can compare that this is the soil altered, is the low velocity. It's about the 1.4 kilometer per second. And then in the bottom is a volcanic weak altered acrylic. It's low velocity also, and then acrylic also. And then in the to 1,000 to 200 meters. This is the identified by advanced acrylic. It's associated with high shear wave velocity. It's the result is we have compared by the well prognosis in this area. And then because of this area is the new area it's not the is still we maybe in the 2 or 3 years will the apa itu PLTP itu PLTP itu PLTP geothermal power plant will build in this area, but in this method maybe in this area is different area. Sorry, it's the different area. The area is in Sumatra power plant. There are the information, the well logging production or well logging injection. We have compared about this result of ambient noise tomography method. This area is the success production. This is the information, the success production. And then this is the success production. But in this area is the fail. It's not success. It's the fail when they try to direction in the wrong structure. So the geophysics is have the important role in the successful of the geothermal production. This is the another line. This is the fail, success, and success, and this is the fail injection, fail the well logging. We can compare with the ambient with the magnetotelluric result. This is in the top is the ambient noise tomography result from shear wave velocity. The velocity result from ambient tomography. In the bottom is the magnetotelluric result. If we just use the magnetotelluric result, maybe like that, you can get the fail well logging. You can fail the trajectory. This is the we used only this result, maybe we can direct your well in this area. Up to you in the area. But in the fact, this is the so many fail injection in this area. So ambient noise tomography came to this field 10 years ago, and then we can answer why this well success, why and this location fail. So after it, they use this structure to get the information, the subsurface, to get the success well logging production in the next future. Thank you very much. Arigato. Matur nuwun. Assalamualaikum warahmatullahi wabarakatuh.
Okay, thank you very much from Mr. Agustia. I think that one is a really interesting presentation about passive seismic. Mr. Agustia present about the AMT, HVSR, horizontal, vertical spectrum ratio, and also tell about the spark from the theory, acquisition, processing until interpretation. So I hope that this interesting presentation will have more question from you. So if you have any question, I will open for the first session is for 3 questions. Is there any one of you want to ask about passive seismic to Mr. Agustia? Okay, please.
Monggo, Pak. Nah, jadi so if you use the ambient tomography, the if targeting, if you can get depend on the turn of the regional area. At if we our target is depend on the target. If we have target in 1 kilometer, so in 1 kilometer in the
Bagus
target.
dia.
Yeah.
Maybe you can use your mic.
Oh ya, sorry.
So the
Okay.
audience
Siap,
can
siap.
hear.
Suaranya gede banget. If we have a target of 500 meter in the top, and then if we have a target 7,000 meter in the bottom, the part of the bottom, so I can use the space, the nearest the distance of each station. I can use the 500 meters. So, but in the launch apa ya, terjauh, the because our target is 500 kilometer, 500 meters in the shallower structure. I can install seismograph with the nearest distance is about 500 meters. But if I get the 7 kilometers, so I have to install the terluar itu apa terluar itu? Seismograph terluar, Pak. The regional seismograph, we have to maybe it's about more than 10 kilometers. So I can get the resolution about the 500 until 7 kilometers in the good resolution. But in AVSR, it's because in AVSR it's little bit different because AVSR is single station method. So the distance is depend on our parameter. But the maximum parameter, I think we have compare with the gamma ray or resistivity acquisition. This is the resistivity result, Pak Udi. This is the resistivity. This is the Nakamura or HVSR single station method. This is the we have compare. It's good for 100, 200 until 500 is too much. I think 200 in the tip. So it's depend on the parameter if we use the HVSR, but in the ambient tomography is depend on our grid. It's like that. Thank you, Paudi.
Okay, so for the next question, there is a question from the Zoom meeting from Dandi Baskoro. Can the HVSR and ANT methods be used to identify the distribution of acidic zones or the distribution of magmatic gases?
Actually, maybe we can different about the acid or the other or clay cap, but in the geophysics we just get the identify the physics of the rock, of information, the physics of the rock. Yeah, if about maybe if the axis zone is uh, associated with the low velocity, maybe we can identify it. But if the acid or clay cap it have the same information, I think it's a little bit different, little bit difficult.
Okay, so the next question is, what if we have a field is not located in a coastal zone where ocean wave propagation is the main source of ANT data? Can the signal from ANT data still be recorded, or aside from ocean waves, what the other source can replace them?
Okay, thank you Pak Dandi ya. Thank you Pak Dandi Baskoro. Wait, I think the propagation, the ground roll propagation is can reach the all area, and then you can see that this area in the center part of Sumatra. It's not the near in the coastal, but it's the central part of Sumatra. But this signal is still recorded by the seismograph. Thank you, Pak Dandi.
So yeah, I hope the answer from Mr. Agustia can answering for the Pak Dandi ya. So is there any question from this participant in this room? Okay, wait.
Pak Yoga.
So there is a question from Pak Yoga Kurniawan. Thank you, Mr. Aditya, for your presentation. It was interesting for me because a passive seismic is very useful in geothermal exploration and exploitation, and it can also be integrated with magnetotelluric data. What I want to ask is regarding data acquisition, especially for micro earthquake data, which take a long time. Can this micro earthquake data also be used in ANT processing? If so, at what stage is the micro earthquake data used in ANT processing? And also, can the ANT inversion result be correlated with the VV per PS micro earthquake data in geothermal production field?
Ya, matur nuwun Pak Yoga. I think we can use the ambient tomography, micro earthquake data, because in the maybe in 10 years ago we processed the all ambient tomography is from the data that dedicated for ambient for micro earthquake monitoring. But it's if micro earthquake data, it's only maybe it's only 5 station like in the Pertamina or Star Energy geothermal field. I think it's a little bit difficult if we to get the good resolution. Yeah, but it can. If it can, we can use it. Maybe for the example in the Meramex data in Jogja until Meramex is almost in the Central Java until Jogja, Pak ya. It's a Meramex data. It's data from micro earthquake, but by Pak Zulfakriza ITB, he processed for ambient tomography. So it's very possible. And then Takes microtic. Yeah. And then the third is the ambient information result can be, yes, it can correlate, but and then we can in the ambient tomography, it's not also VS that we that we resulted, but we produce the VP and density also. So we can get the Poisson ratio also, so we can that in production to get the monitoring. I think we can try maybe we can collaborate with about the monitoring about the production field. We have data for in the some area is actually in the power plant. Some of we have no we get the data in 5 power plant, so we can collaborate how to monitor the production field in our in my tax is only Q physics, but in Qology I'm not too not to expert. Maybe Pak Yoga one day we can collaborate again with Pak Uki also, Pak Fami also. Maybe we can collaborate. Maybe it's in interest if we can start from the Telemoyo field, because in the previous WKP, this WKP is stopped, and then the government take again this WKP and then give to PLN. PLN is not good, not good. I think someday we can propose this Telemoyo to the DSS, Pak. Maybe to Pak Jatmiko. I think Pak is your close friend, I think. The same age, I think. Maybe we can propose to Telemoyo, because no, the DSS is is in these years they buy 6 WKP, Pak. 6 field. And we just process the exploration in the 2 field. Maybe next month we will process again in the 4 field again in the maybe one is in the Garut, and the others is in the eastern Indonesia, and then the 2 is in the Sumatra. I don't know. Telemoyo is, I think, cancels by DSS. I don't know why. Okay, see you again, Pak Yoga.
So we still have a time. Is there any question from this room? From Kyushu, you have question want to ask to Mr. Agustia, or from Diponegoro University, ITS, UNES. Monggo, Pak Ali, silakan.
Maybe we can compare. Oh, thank you, Ali. I think we can compare the data outflow. Wait, I will show you our results. This is the fracture to identify the outflow. We can identify the clay cap in the structure, and then we can find the middle of the shear velocity in this scale. Yeah, middle in the scale. I mean, this is the reservoir, and this is the high velocity is identified by the heat source. So we can see if the in this area is dominated by low velocity, is identified by reservoir of the geothermal. So where is the upflow or where is the I think for this model is not important again. I think like that, Sally. Thank you very much.
Okay, thank you. Is there any question? Okay, may I ask Mr. Agustia?
Oh, monggo.
Okay, this one really interesting topics for me, for INT itself. The one that I want to ask you is about, is there any chance for INT in oil and gas exploration, and how can the INT processing for the oil and gas exploration itself, is it the same like the active reflection seismic or not?
Actually, we have compare maybe in not this presentation as because the another topic. We have compared to active seismic from the El Nusa field when he processed the acquisition in the some oil and gas field from the Pertamina area. It's identical, but just use the Nakamura method. HVSR, just HVSR method. I think if we use the ambient tomography method, if we compare in the one line, I think enough using the HVSR method. But in the large area, we can use the ambient tomography method. We can choose the best method depend on the area also.
So it depends on the area. When the area is quite small, so we just use the HVSR method. And if the large scale, so we use the INT
and the INT method. Yeah.
Okay, thank you very much. So another question from participant. Okay.
This Vice Pierre from Diponegoro University, Physics Department, 2024. I want to ask, what are the main challenges in design efficient patches for ray tracking in areas with complex topography? For example, hills or mountains, and whether there is a scale limit or not, and why use parallelograms as the design? Why not circles or other shapes? Thank you.
Yeah. I think circle or grading. I mean, grading. We use the grading. Grading is the best interpolation result. We can get the best result depend on the circle acquisition. I think it's the best. You can choose try to maybe some data. You can use the circle or grid. Yeah. Grid is the best method to the acquisition. In the second, this area. Sorry, the first question about how difficult or sorry.
What are the main challenges in design efficient patches for ray tracking in areas with complex topography? Problems.
Yeah. I think it's we can about the topography in the geothermal is if in geothermal we always get the we always get the bed topography. I call it the bed topography. It's so hard to reach some location is too hard. I think maybe in this no our team I think. Yeah, maybe in Atin is a friend of the Alice friend from UE. It's in maybe in the pet topography I think we can choose the first is we can choose the good people and the strong people to get this area. So if you can get it, so maybe you can finish your acquisition fastly. Is the first. So your cost, you can get the cost efficient. It's like that. It's the simple. Thank you. Yeah, thank you.
Okay. Is there any question? Monggo.
Maybe I want to ask about how can I interpret like a chemical structure like strike slip, normal fault, and trans fault by focal mechanism. That's it.
Firman student ya berarti Mas ya? Pak Firman student.
Oh, not
no.
I'm
Not geophysics.
I'm geophysics, but
Geophysics.
oh yeah, Pak Wirman student.
Ya. How to identify from focal mechanism results like that.
Okay.
Kelihatan kan? Ketong ya Mas. Mechanism. Pola vokal untuk mengidentifikasi to identify the fall mechanism. Nah, it's easy for easily identification. I often to memorize if the like that is the normal.
Okay.
Bolong tengah biasa ku normal. Koyo iki apa donat lah ngono ya. Kan gampang ngono aku Mas.
Okay.
Kalau kebalikannya ya kebalikannya, berarti kan yang nggak normal gitu kan, yang naik gitu. The
Transform.
this the strike is the like that. This is the strike of the fault. This is the direction of the fault.
Okay.
Yeah, this is the normal fault. This is the direction. If this structure is the same focal mechanism result, it is the trigger is the same triggers. If the result is different, so it's the trigger is the different triggers. Maybe from volcanic, or this is the from it will tectonic. It will give the different focal information.
Oh, okay. What's the difference from tectonic product and volcanic product?
If a tectonic product, we will get the same information about the focal, but in the volcanic, it's little bit different. It maybe is different. We can get the different information. Maybe you can get the detection about the focal, the normal fault. Maybe you can get the reverse fault, or maybe you can get the information this the random information if triggers by injection of in the geothermal, or triggered by the volcanic or reservoir movement. Yeah.
Okay.
Like that.
And,
thank you.
Sorry, when in this result, we can use in this product to well targeting in geothermal.
Yeah.
Okay. Thank you.
To help. Just one method. So many method.
Okay. In the clear.
Nanti nggak laku metode yang lain, Mas.
Thank you.
Okay. Thank you very much.
Is there any question for Mr. Agustia about passive seismic in geothermal exploration? All clear?
Yeah. I think enough.
Okay, so maybe this is the end of session 5 from Mr. Agustia. Thank you very much, Mr. Agustia, about your presentation. Thank you for your passive seismic in geothermal exploration presentation. Thank you. We will go to field tomorrow. No, yeah. Okay, so okay, so maybe for course for today, we have 5 session. It's already complete all of them. So thank you very much for Mr. Agustia once more, and then we will give applause to Mr. Agustia for. Okay, so for the next, I will give it back to the MC. Thank you very much.
All right. So I'm sure it's been a very exhausting day, but before we end this event for today, I'm gonna have to brief you guys on what we do tomorrow on the fields. Okay, so this is the guidelines for data collections activities. Before we head to the fields tomorrow, please make sure to install Avenza Maps because it's gonna be crucial for our exploration for tomorrow. Participants will be organized to 2 main teams. Details will be attached later. Maybe the committee members will share to you. Yeah, and be clean. Okay, so there are some recommendations for items to bring. Comfortable clothes, preferably long pants because there's gonna be a lot of dirt and animals. We don't want that on our feet, so it's recommended for us to wear long and comfortable clothes because we will be walking for a long time. And shoes is also really recommended. Yeah, we don't want animals to get on our feet. And if you have any disease like mental, not no, no, no. I'm sorry. I mean, if you have any born by disease, like something that you were born with, make sure to bring your medicines like asthma cap. Just make sure to bring that, and then bring an umbrella, and a hat and a raincoat in case the weather gets moody. Okay, so there's the team division. You could see it for yourself. Yeah. Okay, so for for team one, we got Christiana from Kyushu. Hi, Christiana. Okay, and then we got Dory, also from Kyushu University. We got Mas Indra is not here, so but Mas Indra will be joining team one, and Takuta will be joining team one as well. Sohei Kun will be joining team one as well. Who's that? Oh, you? Wait. Oh yeah, Realtor will be joining team one as well. And then after that, there is Salsabila Koirun Nadifa from Diponegoro University. Liwao Izaid Habibah from Diponegoro University, and oh my god. And then there's Fatima Zuhro Navia. From Diponegoro University will be joining team one as well. There's Sabrina. I'm not sure which one is Sabrina, but you'll be joining team one as well. Nabila. I'm just gonna read out the short names. There's Fifi. I'm not what. There's Wanda as well. Koirul Singhi. Okay, I'm sorry, I cannot read that. Is that you? Oh, sorry, I'm sorry. And then there's Ifan Nur Hania for team one. That's all for team one. And then for team two. Please, for a brief moment. Okay, so from team two, we got Mariam Ali from Kyushu University, and then there is Tofiana. Oh, you, yeah. All right. Tofiana from Kyushu University. There's Akira. You as well. Kyosuke Sosten. Yeah. That's team two from Kyushu University, and then for the rest, there is Nur Iksan from Institute Teknologi 10 November, and then Irham will be joining team two as well from Diponegoro University. And then there is Radia Zilka Aini from Diponegoro University. And then there is Rindi Antika Dwi Purnama from Diponegoro University. Claudia as well from Diponegoro University. Octavia Ramadani from Diponegoro University. Meira Aulia Firdausa from Diponegoro University. Atin Nur Siti Khotima from Diponegoro from Diponegoro University. Okay. Okay, ada. There is Adzaki from Diponegoro University will be joining team two as well. And finally, the last member from team two will be Yesha. From Institute Teknologi 10 November. Okay, so from 7 a.m. to 8:30 will be the trip to Gedong Songo of Geothermal Field. So yeah, we will be riding in cars, yes? and we will be riding in cars. And at 8:30 we will begin dividing team 1 and team 2, which have I have read it out to you earlier. Team 1 will be geology, geochemistry, radon tracer, and observation and sampling. The PIC for the team 1 will be Mr. Yoga earlier, Professor Agus, Dr. Rina, and Mr. Ahmad Alim. Yeah. For team 2, we'll be doing geomagnetic acquisition. And for the PIC, you could contact Dr. Udi, Dr. Tony, Dr. Gurnowo, and Miss Ihya. Okay, and then the first session will be going through until 12 a.m. 12 a.m. And then after that, there will be a short break for like 1 hour from 12 to 1 p.m. And then after that, the team will be swapped out for their activities. So when you did geomagnetic acquisition as team 2, you will be doing it as team 1. And when you did all that stuff in team 1, you'll be doing it in team 2. And the PIC will still be the same. Okay, so this is for the third day. Yeah, for the third day, the same schedule as well. You will be going to Gedong Songo at 7 a.m. as well, and then you will be arriving at 8:30. And then for team 1, you'll be doing passive seismic acquisition for geothermal exploration. And for the PIC, it's listed out on the PowerPoint. You could read it out as well. And for team 2, you will be doing gravity acquisition, and the PIC is over there as well. And then there will be another short break for 1 hour. And after that, from 1 p.m., the team will swap out activities, and yeah, after that, it stays the same. Okay, day 1. Oh my God. Okay, so I'm gonna give a short explanation. So there's this little dot over here. This will be the point that we will be measuring on for like for with one measurements tools. Yeah. So all of this basically is gonna be the day 1 route. Yeah, that's gonna be all of it. And for day 2, this is gonna be the point that you're gonna be measuring. This blue circle right here is what you're gonna be measuring. Okay, yeah. So I guess somehow you will be divided into 2 teams. Maybe by 3 p.m. you will be done with all of this, hopefully. I mean, it does rain, you know. And that's all from me for the brief presentation of what we do in the fields. Okay. Okay, so now for the closing ceremony, I guess we have all been through a lot today. We learned some stuff, we laughed together, we talked so much. It's one way we get to know each other, and hopefully this collaboration will bear fruit to future collaborations so that we could meet each other again in the future. I hope that it will be the case. So I would like to add my little words of wisdom from the genius Albert Einstein. Learning should be fun. It shouldn't be a slavery. Yeah. Okay. So without further ado, let's give it our all. As our friends from Kyushu would say, "Seize ganbaro." That's all from me. Thank you very much.